Hey guys, it's the Dark Master here, and happy Halloween! In today's spooktacular special, we shall be diving into another iceberg video. Now, to briefly explain what exactly an iceberg is an image meme format that was popularized by the YouTuber Michel with his Super Mario 64 Iceberg released on June 25th, 2020. Icebergs consist of an image of an iceberg made by the photo artist Ralph Clevinger that has a list of related topics arranged in a series of levels, with the most well-known stuff at the top and increasingly obscure and, in some cases, more disturbing, though this is not always the case, on the bottom parts of it. In the past 5 years, I've had this tradition of doing iceberg videos for Halloween. The first two were on Kirby Right Back at You Ninjago, and those were ones that people had already made, but still worth watching if you like those sort of niche subjects. Last year, though, I shifted to making my own iceberg, as there really wasn't one tight nature that interested me or hadn't already been done to death. And really, I realized how underappreciated extinct invertebrates are. This year, I decided to continue this trend and discuss another group of very underappreciated crawling things that I like, amphibians, which are also my favorite tetrapod group. Amphibians, who we shall see, were once far more diverse than they are now. Now, much like the term invertebrate, I think a little explanation is needed. The term amphibian comes from the adjective amphibious, which itself comes from the Greek words amphi, meaning dual or double, and bios, which means life. And, that's also where the term bio in biology comes from. This refers to the fact that how, in general, amphibians spend their young lives in water while the adults can live on land. There's a lot more nuance to that, both in terms of extinct and still living amphibians, and plenty of exceptions, but for now, let's just push that to the side, as it's not really relevant here. And much like the invertebrate term, technically it's not a monophyletic group, with the term basically being applied to any tetrapod that's not either clearly a reptile, bird, mammal, or an earlier form like a fish. But unlike invertebrates, technically it can actually be a monophyletic term depending on the context, especially if you're referring to the clade Batrachomorpha, or subclass Lissamphibia, which are a monophyletic group that includes all modern amphibians. For the sake of this video, I've decided to take a more broad definition that most average people use. This is for 3 reasons. 1, I think that it will allow for a more rich, comprehensive iceberg video. 2, if I didn't, it would exclude many extinct animals that are famous/well-known as being extinct quote-unquote amphibians, and thus are worth talking about in this sort of video. Thirdly, I don't think any of them would really fit into any other iceberg. As such, I wouldn't have an excuse to talk about them ever again. Also, it should be said that past a certain point, all of these critters become equally obscure to the average person, so please, don't get upset if, say, you think an entry like Pangerpeton should be higher than something or someone else. So, we're just here to have fun. Also, these will be brief coverages. Frankly, I could make entire videos about some of these entries, and I hope to do so at some point in the future, but I do have to keep this video at a somewhat reasonable length. But without further ado, let us start this iceberg with the air above it. These are the all-stars, those animals/concepts of amphibians that even those with no knowledge of paleontology probably know thanks to word of mouth and pop culture. Ichthyostega. Alright, so this entry refers to perhaps the most famous extinct amphibian, Ichthyostega. It was discovered in 1932 and was for a very long time the missing link between fish and more derived tetrapods before many other early ones were found. It lived around 365 to 360 million years ago in the Fennomanian stage of the late Devonian in what is now Greenland, and it would have been fairly big, reaching about 4.9 feet in length, and would have been rather awkward on land, moving more like a seal than, say, a salamander, kind of like a giant mudskipper too, if you think about it. While no longer thought of being the true ancestor of modern tetrapods, it no doubt helped shine a light on this period better than any stem tetrapod before or after. Holocene amphibian mass extinction. Alright, so for this intro, we spring forward to the present to see a very depressing phenomena. You see, in recent centuries, there's been an ecological crisis caused by the advancement of humanity. But the group most impacted by this has to be, sadly, the amphibians. It is the reason so many recent animals are on this iceberg. While caecilians seem to have been mostly unimpacted due to their fossorial habits, 3 salamanders and 33 frog species have been lost. The reasons for this decline in amphibians is multifaceted, with climate change, habitat loss, diseases, pollution, invasive species, and even sound pollution believed to cause amphibian decline, which is now 211 times greater than the average extinction rate. Luckily, there is hope, for we the people can change our ways, lest our amphibian brothers die out, like so many before them. Eriops. So this entry refers to a species of temnospondyl, don't worry about that term, we'll discuss it later, amphibian Eriops megacephalus, dating to the Gazzellian stage of the Pennsylvanian and lasting until the Kungurian stage of the Permian, from 299 to 273 million years ago or so. It was quite large in terms of size, reaching a total length of 9 feet 10 inches, of which 24 inches were the massive head, which gave the animal its name, which in Latin means drawn out face. It would have been a semi-aquatic predator, but unlike others, it had powerful, robust legs that would have allowed it to be more proficient on land. It is known from what is now Texas and New Mexico. It is often depicted alongside more famous animals like Dimetrodon, which it did coexist with. Lissamphibia. So, I actually mentioned this term earlier in the intro, but basically, the lissamphibia is a subclass that refers to the group that includes all modern amphibians. There are 3 groups: the batrachia, which are frog salamanders and their stem relatives, the very mysterious gymnophonia, which are the caecilians and their stem relatives, and lastly are the entirely extinct allocaudata. The origins of this group are highly contentious, and I will be talking about that many times, as well as some of their many representatives on this iceberg later. Golden toad. Speaking of lissamphibia, the golden toad, Incilius peregrinens, was, true to its name, a toad that was golden coloration, specifically in males, while females were more varied in their color, with subdued colors that just had, more of a toad-like appearance. Males were also smaller, ranging from 1.5 to 1.8 inches in length, while females could reach 2.2 inches. They were endemic to a 1.5 square mile patch of dwarf cloud forest in what is now Costa Rica, and were described in 1966 by noted zoologist J. Matthews Savage. Sadly, in 1989, the species went extinct due to a disputed combination of reasons, such as climate change and a chytrid fungus disease. Since its extinction, though, it has become a common icon for conservation and has spurred further efforts to save other amphibians from a similar fate. And honestly, it's very beautiful, even if it's long gone. Fishapod. So, this is a term often used by media to refer to certain stem tetrapods like Tiktaalik or Quigcatania, though some paleontologists also use it. It's a fairly useful descriptor for these creatures as they had the traits of fish and tetrapods. I do find it amusing, though, it hasn't gotten the same ire that terms like living fossil have, because much like that term, it doesn't really describe a whole truth with 100% accuracy, and just kind of shows how inconsistent the paleo community is when it comes to outrage over certain terms. Because, strictly speaking, these aren't really fishopods, they're just really, really, really early tetrapods. Acanthostega. Alright, for this entry, we see another very early amphibian, Acanthostega gunari, that lived in the Phanomanian stage of the late Devonian around 365 million years ago, in what is now eastern Greenland, which back then was a swampy area. It was a relatively small creature, only reaching 24 inches in length. Interestingly, it had well-developed hands, but likely couldn't walk all that well due to lacking wrists, and thus was unable to move its legs in a weight-bearing manner, and likely used them more to help get through weedy areas in water. After Ichthyostega, it is likely the second most famous prehistoric amphibian of all time, and would have lived as an ambush hunter. Koolasuchus. Continuing with this entry, we leap forwards from some of the oldest notable prehistoric extinct amphibians to one of the last. Koolasuchus cleelandi was the last of the classic temnospondyls, if we exclude the potential members of lissamphibia, but we'll get to that controversy in a bit. Back on topic, this creature was a massive aquatic predator that reached 9.8 feet in length with a broad head. It lived in the early Cretaceous from the Barrenian to Aptian stage, around 125 to 120 million years ago in Victoria, Australia, proving the land down under has always been a kind of a unique place. Large temnospondyls like this ones filled the niches of crocodilians all around the world, but the end Permian and end Triassic extinctions really beat them down, allowing crocodiles to outcompete most of the survivors. But you might be asking, why did this guy survive? Well, it's in the name, Koolasuchus. It lived in an area that at the time was in the Antarctic Circle and was too cool for crocodilians to survive. Sadly, when temperatures warmed later, the crocodilians came and pushed them to extinction, alongside climate change and potentially other factors like the evolution of fish that would have preyed on their larvae, pushed them finally to their extinction. This creature is most famous for its appearance in the Walking with Dinosaurs Episode 5, Spirits of the Ice Forest, which depicted it well as a living relic, even when dinosaurs were around. Missing link. Alright, so the term missing link, much like the term fishapod, is a term often used by the media to describe recently discovered transitional forms, especially in regards to human evolution, bird evolution, and the transition onto land. It has, much like the term living fossil, become increasingly disliked by the academic elites. They claim that it is impossible, literally, for any fossil organism to be the direct ancestor of humanity. And admittedly, while it is mathematically unlikely given the nature of populations, it is possible that one of these guys literally was our ancestor. And besides, as long as someone believes in evolution, doesn't it really matter if they think that some fossil is their literal ancestor or not? At the end of the day, use the term if you want to, or don't use it if you don't like it. It's really not that big of a deal to get worked up over, as some people seemingly do. Beelzebufo. This entry refers to perhaps the most famous prehistoric frog of all time, Beelzebufo ampinga, also called the devil frog, the devil toad, or the toad from hell. It is known from the Maastrichtian stage of the late Cretaceous around 70 million years ago in what is now Madagascar. While initially hypothesized to have been the size of 16.7 inches, more recent findings have indicated it was slightly smaller, at a size about 9.1 inches. Around the same size as the modern African bullfrog, Pixycephalus adispersus. Though this individual also seems to have been not fully mature, so ultimately an adult may have been larger. Not to mention the individual variation in size seen in all species means that the largest specimen could have been much larger than this fossil indicates. Despite resembling a member of the Ceratopidae, better known as horned toads, it is now thought that these similarities are due to convergent evolution due to filling a similar niche, and instead it is now thought to be a stem hyloidea. Labyrinthiodonts. So this entry refers to a now obsolete subclass grouping of basal tetrapods. They were first used by Richard Owens and were united by teeth with strongly folded enamel that resembled a labyrinth. They also usually had massive skull roofs, optic notches, and complex vertebra shape. It has often been used in art and media, but is now thought to be a paraphyletic collection of early amphibians that just look like giant salamanders, due to that being the basal condition, and are not all that closely related. It would be broken up into several smaller groups, but the situation is frankly far from being cleared up, and there's still a lot of work to be done there. Tiktaalik. Here we see for this entry the most basal creature we will be discussing, Tiktaalik rosé, which lived in the late Fresnian stage of the Devonian, 375 million years ago, in what is now Nunavut, Canada. It is notable for being a key transitional fossil that shows a stage between earlier lobed fin fish and the earliest tetrapods like Ichthyostega and Acanthostega. It was decently sized, reaching about 9.2 feet in length, and it had a neck and crocodile-like head, as well as stronger limbs, but also gills and an elongated torso, plus scales that were much more fish-like. Initially thought of being the ancestor of tetrapods alongside other elpilostegids, but some recent discoveries in the form of the µCT-Scan, which have been a subject of a bit of a controversy, so we'll talk about that later, reveal that it may not have actually been the ancestor, and in all likelihood seems to represent another group of fish that convergently, in a related form, converged on, say, the form of tetrapods, though they were still very, very closely related. Regardless of if Tiktaalik was really a direct ancestor, it really does help illustrate what it may have looked like, though. Diplocaulus. So this entry refers to the genus Diplocaulus, which was a lepospondyle amphibian notable for a pair of horns at the rear of the skull, giving it a boomerang-shaped head. Indeed, its name means in Latin double stalk, in reference to that. It reached around 3.3 feet in length and was fairly successful, with 5 species that emerged in the Caesimovian stage of the Pennsylvanian around 306 million years ago and lasted until the Lopingian stage of the late Permian 255 million years ago, being the last of the Lepospondyli, which are a group that we will eventually reach, so don't worry about it. There has been some debate on what its large head did, ranging from a burrowing tool, a protection for its gills, protection from predators, to even functioning like a hydrofoil. There's also some debate on whether it had a stingray-like set of flaps along its body, or if it was more salamander-like. In my humble opinion, it was likely varied between the species and is arguably one of the most famous of the lepospondyls due to its head, leading to it showing up in a lot of paleo media. Triadobatrachus. This entry refers to Triadobatrachus massinoti, commonly known as the first frog, even if recent finds have sort of challenged that. Dating to the early Triassic around 250 million years ago in Madagascar, there's a lot of frogs found there for some reason, it was a small guy, reaching only 3.9 inches in length, and would have looked a lot like what you might expect the first frog to be, stout body, a cute little tail, but it likely couldn't really jump all that well. But, it's important for our understanding of the evolution of modern amphibians. The gastric brooding frogs. So for our last entry in this first layer of the iceberg, we return to the present and go to the land down under with the genus Rheobatrachus, better known as the gastric brooding frogs. There's actually 2 species, the northern gastric brooding frog, Rheobatrachus vitellinus, and the southern gastric brooding frog, Rheobatrachus silus. In terms of appearance, they kind of just look like your average 2-inch semi-aquatic frog, but this actually makes them stand out from the other, more unusual frogs from Australia, most of which have strange bodies to burrow with to survive in arid areas. But what is far more famous about them is how the females would hold their tadpoles in their stomach until they were developed and then vomit them out. And to think human children are a burden. Sadly, as you might expect, they went extinct due to a combination of habitat loss to their already small range, which was at most only about 770 square miles, as well as the introduction of cycritid fungus, which was introduced by humans and feral pigs and led to the extinction of both species in the early 1980s. And with that, we come to the end of our first layer. As we go to the tip of the iceberg, we leave behind the general public that are aware of paleontology, but we're still covering extremely well-known topics to people who have some awareness of paleontology. And without further ado, let us go on to layer 2, the tip of the iceberg. Temnospondyle. Alright, so this entry refers to a group we've seen before with Koolasuchus, but the Temnospondyles were a massive group that were highly diverse animals that first emerged in the Mississippian and radiated into many groups, which we shall meet later. They ranged from terrestrial small ones that lived and looked much like modern salamanders to over 15-foot aquatic predators. Their name, Temnospondyles, comes from the structure of their vertebrae, with the name meaning a cut vertebrae, which is due to the fact that the vertebrae is divided into several parts. They also may have given rise to modern amphibians, so this is very controversial in terms of a topic and will be the subject of several later entries on this iceberg, so let's just leave it there. The Temnospondyles were around for a very long time, and while the more terrestrial members declined in the later Permian, the semi-aquatic forms thrived, becoming the dominant aquatic and semi-aquatic predators, filling in the niche held by, aforementioned crocodiles, and would continue to dominate past the Great Dying and into the Triassic, though the much less famous end Triassic mass extinction was the final nail in their dominance. But they would continue to linger as relics in the southern hemisphere until 120 million years ago in the early Cretaceous or so. Mastodonsaurus. So this entry refers to one of the largest genera of Temnospondyles and date to the Middle Triassic, and he was huge, with max size estimates ranging from 13 to 20 feet long, though isolated teeth that measured 6 inches long indicate that some exceptional individuals could grow even larger. There are 4 recognized species, also varied in size, with some of them being a little smaller, while others being those giants I referred to. With its short legs and long tail, it would have preyed upon fish, smaller Temnospondyles, younger members of its own species, archosaurs / other terrestrial animals that wandered to use the water to drink. Though in turn, it could fall prey to large croc relatives like Batrachians when they got stuck in the pools during the drought seasons, which happened and led to mass deaths. Batrachomorpha. So, this term you might have heard in the intro of this video if you're paying attention. For context, tetrapods are divided into 2 main groups, excluding some stem forms that we shall discuss later. The one relevant here, the Batrachomorpha, also called amphibia in some sources, includes all animals that are closer to modern amphibians than they are to amniotes, like you and me. Now, what exactly is in this group itself is a huge matter of debate that we'll return to multiple times in this iceberg, but for now, just remember that Batrachomorpha means frog-shaped, and so all things that are more closely related to living amphibians than they are to anything else are batrachomorphs. Roemer's gap. So, this entry refers to what is a supposed gap that once existed in the tetrapod fossil record that lasted from 360 to 345 million years ago, corresponding to the first 15 million years or so of the Mississippian, or as some call it, the early Carboniferous, which leaves a tantalizing period of time between the earliest stem tetrapods like Ichthyostega and the more diverse and derived tetrapod groups of the Pennsylvanian, like the temnospondyls and such. The reasons for this gap include multiple ones, but some of these include, at least in some areas, there seems to have been a great reduction in oxygen, a lack of terrestrial deposits compared to the surrounding time periods, plus the world was still recovering from the end Devonian mass extinction event, which devastated my beloved trilobites, jawless fish, and eurypterids. Luckily, new discoveries like Crassingerinus have helped to partially fill this gap, so we know more. Hynerpeton. This entry refers to another early stem tetrapod that seems to be closer to us than Acanthostega or Ichthyostega are. It lived from 365 to 363 million years ago in the middle to late Phanomanian stage of the Devonian, and nearby what is now Heiner, Pennsylvania, where it got its name from. It is a poorly known animal due to a limited amount of fossils, but is notable for being one of the first to have completely lost their internal gills, and for appearing in the BBC's Walking with Monsters series. Crassingerinus. So this entry refers to a creature I mentioned earlier in the segment on Romer's Gap. Crassingerinus scoticus, true to its name, was found first in Scotland, though some fragments indicate that it may have also lived in West Virginia in the Visean stage of the Middle Mississippi, 345 to 329 million years ago. It is interesting for several reasons. First, it helps fill a gap in the tetrapod paleontological evolutionary history. Second, it has basically useless legs, indicating that it had decided being on land was overrated and effectively becoming the first tetrapod to abandon land for an aquatic existence secondarily. And at 6.5 feet long, it would have been a deadly predator. It's commonly depicted with an unusually high skull, and it turns out that's actually no longer accurate and was due to compression, and instead it would have had one that was more like other early tetrapod groups. Otherwise, it's still an interesting animal, and is most famous due to Nigel Marven wrangling it in Prehistoric Park. Probably not the smartest idea, but I mean, I've never handled massively large amphibians or reptiles, so I can't judge him too much on that. Reptilomorpha. So this particular entry might be a bit confusing, as, after all, what is something that literally means reptile shape doing on an iceberg? Also called panamniota. Where here's the thing. While amniotes are part of that group, there are many smaller stem groups like didecamorphs and psinoromorpha who, despite looking and being more related to reptiles, seemingly would have engaged in amphibious reproduction, such as how we have found tadpoles of Simoria and others, like Chronosuchia and Limnoscalids, would have lived more like amphibians. So I think that they deserve an inclusion here, as I don't think that they would really fit on, say, a reptile or amniote iceberg. Lepospondyls. The Lepospondyli are a highly diverse group of amphibians that were generally smaller than 3 feet in length, with the notable exception of Diplocalus that I discussed before higher up on the iceberg. They filled many niches that the larger Temnospondyli didn't, such as those held by small lizards, eels, caecilians, and newts today. They seem to have been mostly restricted to what became North America, with the exception of, again, Diplocalus, which has been found in Morocco as well. And they were around mostly from the Visean stage of the Mississippian around 346.7 million years ago until the Silurian stage of the early Permian, 298.9 million years ago. Again, there was the exception of Diplocalus, which managed to persist until the late Permian, 255 million years ago, but the Lepospondyli itself is divided into 5 orders. The legless Adelospondyli, the similar Tetrapoda, the fossorial Lycophoria, the mildly controversial Nectridia, and the highly contentious Microsauria, all of which we will meet later. Much like the Labyrinthiodonts, this group has a lot of contention with regards to both where it places, with some studies saying it is Batrachomorpha, others say that it's more related to Reptilomorpha, i.e. closer to reptiles, and what exactly should be included in it is also very contentious, with some groups potentially being basal to other tetrapods and other orders being completely invalid. It's a mess that we're still figuring out, and hopefully it doesn't get abandoned like Labyrinthiodont did. Polydactyly in stem tetrapods. So this entry alludes to how many early tetrapods had many more than 5 digits on each hand, which is the standard nowadays. The reason that this was the case is uncertain, as is uncertain as to why all tetrapods have 5 or less. This is compounded by the existence of Romer's gap, which means that we don't really have much data points from the time, and though that has gotten fixed recently, it's still a bit of an issue. Indeed, it could very well have been a bottleneck for all we know, or just dumb luck, a mystery for the ages. Polydactyly still happens as birth defects to this very day, though, and it's possible if things had been slightly different, high 5s would be high 7s. Nectridia. Alright, so for this entry, we return to the Lepospondals, as we shall be discussing the most famous of the 5 orders, the Nectridia, which are distinguished by having only one colonoid bone lining the edge of their jaw, while all the other early tetrapods have 3 and an extra set of joints connecting the vertebrae above the typical joint structure of other early tetrapods. They were divided into 3 families, plus 1 basal genera we'll meet later. First and most famous are the boomerang-headed Diplocolidae, which includes Diplocolus itself, which I've talked about before, and many more obscure ones. There's the Scinceridae and the Urocodylidae, all of which we'll meet later, but looked more like newts in general. Seamoria. Here we see the first reptilomorph of the iceberg, and the most famous of them due to appearing in the Walking with Monsters BBC television series, where it interacted with Dimetrodon. It lived in what is now Europe and North America during the early Permian. Originally thought to be a reptile, it was however proven to not be one in 1952, with the discovery of a closely related genus having a larva, which had external gills, proving that it reproduced in a non-reptilian way. Currently, there are 3 species are recognized and are believed to have been primarily terrestrial, with a very short tadpole stage due to living in an arid place with wet and dry seasons, much like how certain desert toads live. Microsauria. With this here entry, we return to the Lepospondals with their most contentious order, which is saying much in a group that's already extremely contentious. They were all rather small creatures with short tails and legs, but were varied, with terrestrial lizard-like forms and more aquatic ones as well being known. Generally speaking, they lived in what is now Europe and America from the Pennsylvanian 323 or so million years ago until the early Permian around 298 or so million years ago. However, controversial fossils in Russia and northwestern China indicate that some may have in fact lived as late as the late Permian or early Triassic, making them hypothetically the last of the Lepospondals and outliving Diplocalus, but these are very contentious. However, that is not where the controversy ends, for indeed the very existence of Microsauria is heavily disputed, with some claiming that it is a paraphyletic group and that the order Lyosophia may nest within it, and Microsauria itself is more of sort of a evolutionary grade than a proper group. This is of course also controversial, and for the sake of ease I have decided to treat Microsauria as an order for this video and include several groups like the Hapistoparellidae, the Microbronchidae, the Tudinonidae, and the Rucrumbostralia, all of which we will meet later. Plus, even if it ends up no longer being a valid group, It shows up in enough literature that I think it earned its place on the iceberg. Origins of modern amphibians. Ooh boy, so this entry refers to perhaps the most highly contentious subject that I will be discussing. Fitting that I put it on the tip of the iceberg itself. So the origins of modern amphibians has been and still is a pretty big debate, with various hypotheses such as them coming from the lepospondylus, emerging from the temnospondyli. Some have claimed that amphibians aren't even a monophyletic group. Some of this school thought that frogs evolved from temnospondyls, while salamanders and caecilians evolved from a completely separate lineage of fish. Others argued that salamanders and caecilians evolved from microsauria, while frogs came from temnospondyls. Some claimed that all three evolved on their own. More recently, it's been found that temnospondyle view is kinda more solid as the ancestor for frogs and salamanders, but this is shaky, with many valid arguments and evidence for amphibians coming from either one sole temnospondyle group or two, with salamanders and frogs being considered more related to one another than they are to caecilians, who evolved from a completely different group of temnospondyls. But why all the confusion? Well, you see, Lissamphibia's fossil record is very patchy, as the oldest fossils of the group date to the end of the early Triassic and were already pretty derived, so reveal little of their origins, which were earlier in the Triassic or even the Permian. Speaking of, due to their small size, Lissamphibians, like frogs, are way less likely to fossilize compared to more robust skeletons of stuff like, temnospondyls. Plus, speaking of them, at the time there were loads of tiny amphibians of all sorts of lineages, many of which convergently resembled what such an ancestor would have looked like. So, even if we do find one that looks like it could be the ancestor, it could very well be an unrelated form. All in all, it's a big, messy mystery for which no one has a solid answer, and anyone who does say that is lying to you. Diploceraspis. So this entry refers to a genus of diplocollid lepospondyle that lived during the early Permian and was now in North America 299 to around 270 million years ago. It's basically a less famous relative of Diplocollus, only reaching 18.11 inches long, but has appeared in a few video games. Allocaudata. So here we have an entry that discusses an extinct group of amphibians far closer to modern ones. The order Allocaudata, more commonly referred to the Albanerpetontids due to that being the only family in the order, were the sister group to all living amphibians. Despite close resemblance to salamanders, this was more due to the ancestor of these groups all generally looking like salamanders, as opposed to any close relationship. They had several traits greatly different than them. These includes fish-like scales embedded in their skin that would have made them kind of look like lizards. In fact, one of my favorite YouTubers, Paleoanalysis, accidentally used an image of one in place of a lizard, but that's just a funny little mistake. Nothing serious. His videos are otherwise amazing, and you should go subscribe to him. Some also had a ballistic tongue, like those of chameleons. In life, they were fairly small and unremarkable, though they went, interestingly enough, through direct development, i.e. they produced young that looked like miniature versions of themselves as opposed to metamorphosis, and would have been ambush predators in both wet and dry regions of the northern hemisphere, like Morocco, Eurasia, and North America. They emerged in the Bathonian stage of the Middle Jurassic, around 168 million years ago or so, though they likely originated before then. The fossil record is notoriously incomplete and lasted until very, very recently in the Galasian stage of the early Pleistocene around 2 million years ago. So we just missed these wonderful creatures, which is a darn shame, honestly. Proterogyrinus. So this entry refers to an extinct genus of tetrapods found in the group Imbolomeri, which we shall discuss in more detail later, but for now, Proterogyrinus is known from what is now Scotland and West Virginia rocks, from the Serptocovian stage of the late Mississippian around 331 to 333 million years ago. It is notable for having more robust legs with fully ossified ankles, meaning that it could walk/hunt on land more easily than other early stem tetrapods. It also had a taller head, indicating a more powerful bite. It is most famous for its appearance in the BBC Walking with Monsters series, though it isn't really mentioned by name in that one. The Stegas. So, this term that this entry is about refers to a nickname given to a loose collection of basal tetrapods with names that end in stega. By the way, this is the same term that gives Stegosaurus their names, which means roofed lizard, as stega in Latin means roofed. As to why this name is so common in early amphibians, well, Ichthyostega, back when it was described, was thought as being a mere fish, and it had a short roof-like skull, hence its name. Later, many other early amphibians were named after this animal, thus getting the name stega, even if it's not necessarily as prominent in terms of its roof-shaped head here. Stereospondyle. So for this last injury in the layer, we have come back again to the temnospondylus in the Stereospondyle or Stereospondylus, which were a suborder of said group that emerged in the early Permian, but were fairly minor parts of the fauna at the time. But after the end Permian mass extinction event wiped out a lot of their competition, they radiated into a huge number of forms, which we shall meet later in this iceberg. They were also the last surviving group of traditional temnospondyls, not counting, obviously, whether or not modern amphibians are descended from them, making it to the early Cretaceous with Koolasuchus, while other temnospondyls were decimated by the end-Triassic mass extinction event and the diversification of pseudosuchians. Stereospondylus were very successful, ranging from small terrestrial forms to massive aquatic predators with reduced limbs, and would have filled many niches like those of alligators or alligator snapping turtles as benthic ambush predators. They may have even given rise to caecilians, thus still live today, but that is heavily disputed, and we'll talk about that later. And with that, we end yet another layer as we dive into the surface waters, leaving behind the normies and average casual enthusiasts as we cover things that only paleontologists and hardcore paleontologist enthusiasts know. Rhinosuchus. For this entry, we shall be covering the last animal to appear in the Walking With documentary series, Rhinosuchus, though sadly in the documentary Walking With Monsters it's only inaccurately called a labyrinthodont, which is wrong on so many levels, and only named as such in the supplementary book few bought. Back on topic, Rhinosuchus lived during the Guadalupian stage of the late Cretaceous around 273 to 259 million years ago in what is now South Africa. It was a decently sized animal, reaching about 10 feet in length, 220.4 pounds, and could live for up to 30 years according to some studies. Tulurpeton. This next entry refers to a genus of stem tetrapods that lived around 365 million years ago in the Phanomanian stage of the late Devonian, in what is now the Tula region of western Russia. It is notable for possessing more robust legs than earlier forms like Ichthyostega and Acanthostega, and lived in more coastal areas. Legreneur. So this entry refers to a family of stem tetrapods. In fact, they are the most stem of the families, not counting standalone genera like, Ichthyostega. They were endemic to what is now Europe. They didn't last that long, though, and contained only 3 genera: Legreneur, Vertebrata, and Oburoichthyes. One of these we'll meet lower down. Tetrapoda. So with this entry, we return to cover another order of small amphibians. The Tetrapoda were a highly specialized group notable for being the first tetrapods to completely lose their legs, which is something we'll see a lot in this iceberg. They are believed to have filled a niche akin to caecilian/snakes of today, crawling around in leaf litter and in general just being sort of sneaky like that. One genus, Pelagiothelontia, even had its jaws being much lighter, allowing it to open its mouth wide, like a modern snake would have been able to. Now, given the highly derived nature of even their earliest members, placing the Tetrapoda within the family tree of life has been a contentious affair. They were, due to features of their vertebrae, often thought of being related to the Nectrida and thus Lepospondyle. However, recent research has instead, based on the internal features of the head, indicates that they may have diverged from the rest of tetrapods shortly after the origins of digits themselves, making them much more ancient. Regardless of where they are placed, they were an amazing group that lasted from the Mississippian to early Permian, around 336 to 270 or so million years ago. Diplocaulids. So this entry refers to the family Diplocaulidae, which we've met before when we discussed Diplocalus and Diploceraspis, but it was actually a whole family with several other genera like the basal Keraturpeton, which reached around 12 inches long and lacked the long horns that the rest of the group is known for. There was Batrachiodurpedon, known from what is now Northumberland, England, and the obscure Deronedon. Simoromorpha. Alright, so for this entry, we should be discussing the Simoromorpha, which we mentioned briefly in the Simoria segment earlier on. It got the most attention, but in reality there was an entire order of related creatures that are distinguished by having semi-aquatic larvae, but as they matured they became more reptile-like. Most were fairly small, about 1 foot or so, lizard-like creatures, though one genus of basal position, Inosuchus, was 5 feet long and a fully aquatic predator. Outside of a few disputed taxa, they were divided into 3 families: the monotypic Carpisciosauridae, the Discosauruscidae, which had 4 genera, notably the one is Discosauricus, which helped to illustrate how this order matured, and Simoridae, which includes the famous Simoria and its closest relatives. Amphibiformes. So this entry refers to what has been classically considered the closest relatives of modern amphibians, though as I've said, this is very contentious. These guys would have looked a lot like frog/salamanders hybrids, and are diagnosed by a palatine and ectopterygoid bone that has become a narrow strut, and the absence of a basculoorbital and a supraoccipital. These are including many notable members of this group that we'll meet later on, so let's save that for later, but this is a group that is interesting in its own right, so that's why I got an entry here. Rhinisuchidae. So this entry refers to a family of temnospondyls that lived from the Guadalupian stage of the Permian 279 or so million years ago until the early Triassic 247 million years ago or so. They were distinguished by unique features of the otic notches near the anterior of the skull. Generally aquatic, some could enter into terrestrial burrows to rest, and they achieved a worldwide distribution, though they were most common in the high altitudes of what is now Africa and South America. They helped solve Weierstrass's paradox, but that is something we'll return to later in this iceberg. Carpinskiosaurus. So this entry refers to the sole genus Carpinskiosaurus of the family Carpinskiosauridae, which contained 2 species and lived in what is now Russia, the largest of which reached a max size of 29.5 inches long. Kinda small, extremely obscure, but still kinda cool. Gerothorax. This entry refers to a species of temnospondyls of the Plangiosauridae, Gerothorax pulcherimus. It was a bit small, only about 3 feet or so in length, with a squat, flattened body that would have hidden beneath sediment, where it would ambush anything that could fit in its wide mouth, kind of like a flounder or an alligator snapping turtle, and could open its mouth uniquely like a toilet seat to suck up prey. Now, this might not sound all that impressive, but before you judge it too harshly, understand that this one species lasted 35 million years ago from the Candian stage of the Middle Permian around 242 million years ago until the Ratian stage 205 million years ago. Most genera don't last that long, let alone individual species. Jerobatrachus. So this entry refers to the temnospondyle Jerobatrachus hautoni from the Caesarulean stage of the early Permian around 290 million years ago in what is now Baylor County, Texas. Dubbed the frogamander by the press, and it does kind of look like a small frog salamander hybrid reaching about 4.3 inches long. It is commonly thought to be closely related to the common ancestor of all living amphibians, but likely isn't the ancestor itself. Triadobatrachus. So this entry sees another temnospondyle that dates to the early Permian, specifically the Acelian to Congorian stage 299 to 272 million years ago, from what is now known as the country of Brazil. It is notable for being the largest amphibian to ever exist, reaching 29 feet or so, though the maximum size is a bit disputed. While Mastodontosaurus likely weighed more due to its robust body, Prionosuchus was longer, likely due to its very long gharial-like snout, and lived in a niche akin to modern alligators/crocodiles. Andreas Schurzori. So this entry refers to an extinct species of giant salamander, which is actually the same genus still alive today, living from the late Oligocene around 28 million years ago and lasting until the late Pliocene 2.58 million years ago. It lived in Central Europe and Siberia. Unlike the modern giant salamanders, however, it was far more tolerant of low oxygen conditions and lived in lakes instead of mountain streams. When first discovered, people thought it was like a child drowned in the flood. It also served as the basis for the 1930s sci-fi novel War with the Newts by Karel Capek. Kinda neat. Edopoids. So this entry refers to the most basal clade of temnospondyls and are distinguished by the possession of an intertemporal bone that all later temnospondyls lost, the Edopoida. They were known from the Pennsylvanian to the late Permian around 310 to 252 million years ago in what is now Europe, Asia, and Africa, with the group seemingly evolving in the Euro-American region. Unlike most temnospondyls, they superficially lack the sensory grooves on the skull, which indicates that they were primarily terrestrial due to lacking a lateral line that would have aided them while swimming if they had one. Discosauriskids. So this entry refers to the largest family of the Simoromorpha, the Discosauriskids, which consists of 4 genera, including Makovskia of the Czech Republic, the air-dwelling Arctic Canerpodon, and Discosauricus itself, which helped to reveal how Simoromorphs matured and grew over their lives. Chigutosaurids. So this entry refers to the family Chigutosauridae, which emerged in the early Triassic around 252 million years ago in a form similar to Arenanerpeton. While never the most diverse family, they are notable for being one of the only temnospondyl families that survived the end-Triassic mass extinction event in the southern hemisphere, in the form of such creatures as the up to 8.9-foot-long Siderops of Australia, and more famously, Coolosuchus, which we've talked about earlier. Capitosauria. So this entry refers to a clade of temnospondyls that were sort of the dominant group alongside the Themattosauria, which we will meet later during the Triassic and after the end Permian Great Dying mass extinction event. Their most famous members are the superfamily Mastodontosauroidea, though there are also some interesting basal forms like Edgingerelia, Watsonsuchus, and Calmosuchus. Albanerpeton. So this entry refers to the most famous genus of the Allocaudata, Albanerpeton, which yes did give the sole family in this group its name. It was first discovered in 1976 and considered a salamander, but in 1982 it was realized thanks to the work of Richard Fox and Bruce Mylor to form its own group. In life, it would have been somewhat fossorial and ambushed prey in moist environments, filling a niche akin to that of, say, lungless or mole salamanders. There were 8 species divided mostly into 2 smaller lineages, a robust snouted clade and a gracile snouted clade, generally thought to have first emerged in the Amphibian stage of the Cretaceous around 121 to 113 million years ago, though recent work has argued that these early ones may be their own genus and thus Albanerpeton is limited to the Cenozoic. Regardless, they were the last of the Albanerpetontids, lasting until the Gelasian stage of the early Pleistocene of northern Italy. It really was not the coldness that killed them, however, but a warming dryness that gave rise to the modern Mediterranean climate. And indeed, it might be odd, but ice ages don't necessarily just refer to it getting colder, more so that there's just more ice around, and that can lead to dryness in certain situations. Adelospondyli. This entry sees us go to another order of small, legless amphibians, the Adelospondyli or Adelospondylus, were a fairly rare and short-lived group compared to the more famous Tetrapoda, with only 6 specimens that are part of 5 genera, themselves divided into 2 families that all date to the Serpicovian stage of the late Mississippian around 358.9 to 323.2 million years ago in what is now Scotland. Unlike the arthropods that I mentioned earlier, they also never entirely lost their shoulder girdles, more like legless lizards than, say, full-blown snakes. Traditionally thought to have been part of the Lepospondyli, recent controversial evidence suggests that instead they may have been far more basal and more related to the Colesteidae, which we shall meet later on in this iceberg. Diadectomorpha. So this entry refers to an order of stem reptilomorphs originating in the late Mississippian. They seemingly only started to thrive after the Carboniferous rainforest collapse, and they persisted until the Wupagian stage of the late Permian. They are divided into 3 families, of which we shall meet all of them later. As for where they place in the family tree of life, again, originally thought to be the earliest reptiles, later research indicated that they were non-amniotes. There's also been some claim that they were potentially early synapsids, i.e., our own relatives, but that is heavily disputed, and honestly, we don't fully know where they go. Imbolomeri. So this entry refers to an order of amphibians, the Imbolomeri. We actually met their most famous member, Proterorius, a bit earlier, but the order was much more than that, with around 19 or so genera. They are notable for being the first large carnivorous tetrapods, filling a semi-aquatic niche that would later be filled by the likes of temnospondyls, phytosaurs, and of course modern crocodilians. They were the dominant predatory tetrapod group during the Mississippian and Pennsylvanian, but greatly declined in the early Permian, with only the genus Arcarrunz remaining common, with the last genus, Cercoherpeton, persisting as a relic in the Permian, recently discovered in 2020 in what is now China and was much further north than usual. Now, where exactly these guys fit in the Tree of Life is very disputed. Some say they are reptilomorphs, others say they are more basal tetrapods that predate the split between reptilomorphs and batrachomorphs. We just don't really know. Cochleosaurids. So, for this entry, we return to the temnospondyls, the Cochleosauridae, which were the most basal family of temnospondyls, emerging in the Pennsylvania 310 million years ago or so, with 7 or so genera. They were fairly diverse, middle-sized predators represented by Cochleosaurus and Cinoprosopus, though one genus we will meet later lasted until the Lopingian stage of the late Permian in Niger. Mountain mist frog. So for the final entry of this layer, we return to the present to discuss a far more recent loss, with Rhinoidea nilacanensis, better known as the mountain mist frog or the Nicala frog, which was a sort of kind of small little frog that lived in the tropical rainforests of Denubula State Forest, Atherton, and Carbine tablelands of Australia. They laid eggs underneath rocks in rivers, and tadpoles had these cute little sucker-like mouths to stick on to avoid being washed away. Sadly, in 2022, they were declared extinct thanks to a combination of habitat loss, feral pigs, and cyrid fungus. It luckily still has three living relatives: the common mist frog, Rhinoides rehostala, the torrent tree frog, Rhinoidea notis, and the armored frog, Rhinoidea lorica. With that, we come to the end of this layer. From here on out, only amphibian specialists and enthusiasts are likely to know what we're talking about as we come to the bottom of the iceberg itself. Parmastega. So, this entry refers to a very basal stem amphibian that dated to the early Phantomanian stage of the Devonian, around 372 million years ago, in what is now Russia. It helped to solve the mystery of the earliest tetrapod footprints and would have lived as an aquatic hunter of invertebrates and smaller animals, reaching about 51 inches in length. Baphetids. So with this entry, we go to another obscure group of stem tetrapods, the superfamily Baphetoidea, though sometimes this term is restricted specifically to the family Baphetidae, excluding some stem genera, one of which we shall discuss later. Best represented by the genera Megalocephalus and Loxoma. These were large animals, up to 14 feet long, fish hunters, armed with needle-like teeth. Though the general lack of body fossils means that our knowledge of them is limited. They are distinguished from their kin, the Imbolomeri, that we met earlier, by a flat skull and their cheeks being sutured together with the skull roof. They prowled the waters of Europe and possibly Canada from the Namurzian stage of the Mississippian 376 million years ago until the Westphalian stage of the Pennsylvanian around 307 million years ago. Diadectids. So this entry refers to the family Diadectidae, which was the largest, most diverse, and most well-known group of Diadecomorpha I mentioned earlier. While the earliest members, like Orbates, were fairly average lizard-like creatures that would have been generalistic omnivores, they would later give rise to the likes of Dias, Parcus, and Diadectes, which are amazing due to being the first tetrapod groups to become full-on herbivores and the first fully terrestrial animals to reach megafaunal size thanks to their robust legs, and they spread across northern Pangaea. Vegas Valley leopard frog. So this entry refers to a bit of a contentious topic. You see, the Vegas Valley leopard frog, Lithobates fisheri, also called the Las Vegas leopard frog, was a species of leopard frog that, true to its name, was known from, the Las Vegas Valley, as well as the surrounding area in Tule Springs of southern Nevada. Last collected back in January 13th, 1942 by the herpetologist A. Vonderhorst. Afterwards, it was thought to have gone extinct, thus being the first and only endemic frog in the U.S. to go extinct. However, it was found that after comparisons between DNA of 10 preserved specimens, it was found that it was actually identical to the Chiricahua leopard frog, Lithobates chiracuhensis. So luckily, we haven't lost this species, as it never existed in the first place. Elginurpeton. So this entry refers to a species of stem tetrapods, Elginurpeton pancherni, which lived in the late Phoenician stage of the late Devonian 375 million years ago in what is now the UK. It is notable for having an unusually thin set of jaws that allowed for quick bites at fast prey, sort of akin to a modern gharial, and was given a whole family of its own, the Elginurpedontidae, in its name. Edops. So this entry refers to the temnospondyl species Edops cragi. It was an average-sized animal of about 6.6 feet long and lived from the late Pennsylvanian to the early Permian around 303.4 to 290 million years ago in what is now north central Texas. It got its name, which in Latin means swelling face, from the basal pattern of various bones at the back end of the skull, instead of being fused into one like in later temnospondyls. Schurepeton. So this entry refers to a genus of allocaudata amphibians called Schurepeton izagi. It is known for mostly a skull found in the Quangjing Formation that dates to the early Cretaceous, around 145 to 129.4 million years ago. It is notable for being the first representative of the group found in East Asia, indicating that they were more widespread than they were first thought to be. Diadectes. So this entry refers to the most famous genus of diadectomorphs, amphibians, known. Diadectes was fairly successful, with 6 species that lasted from the Arctisian stage of the early Permian 290 million years ago to the Kungarian stage of the early Permian 272 million years ago. It was a large animal reaching 10 feet long and with broad teeth was a herbivore, the first large terrestrial one to ever exist. Plagiosauroids. So this entry refers to a superfamily of temnospondyls that are fairly successful ambush predators that lived throughout the Triassic 252.3 to 201.3 million years ago. We've already met their most famous member that lived during the Permian, but as we shall see even more of them later, let us leave this for now, but they were very diverse. Pantylids. So this refers to the small, quote-unquote, Microsauria family of amphibians, Pantylidae. In spite of their juvenile name, they were fairly small, average-looking critters. There are 2 or 3 genera generally considered to have been part of this family. The most notable is Pantylus cordatus, which lived in the early Permian in North America, that was about 10 inches in length, with a big head, short tail, and robust legs that indicate a terrestrial life chasing after invertebrates. Platyhystrix. So this entry refers to the small temnospondyl Platyhystrix rugosus. It lived during the boundary between the Pennsylvanian 299 million years ago and the early Permian 279 million years ago in what is now the United States Southwest. It lived alongside such famous animals like Dimetrodon and Edaphosaurus, and much like those, it had a cool tail. This indicates that it was mostly terrestrial, and as such, the sail is used for temperature control and would have been little use underwater. Plus, the ecology of the region indicates it was a desert area. Really cool. Electrorana limose. So this entry refers to a 0.79-inch frog that is notable for a few reasons. First, it is one of the oldest frogs known to have inhabited a tropical rainforest, an area that normally has very poor preservation. And taxonomically, it falls outside of the Neobatracha, which is the group that contains 95% or so of all living frogs. But what it is most probably well known for is being found in the highly controversial Burmese amber. If you'd like to learn more about that, I made a whole documentary about it for last year's Christmas special. But to keep it brief, there's a lot of accusations of blood, amber, funding / causing the Myanmar Civil War. It's of course not true, and there's a lot more info to that, and a bunch of misinformation spread by likes of Paleo Twitter, Mark Whitten, and several other people like PaleoStream, who went so far as to fully disqualify entries into a speculative evolution challenge based on the perception of having allegedly supported Burmese amber, which never happened. Back on topic, this is a wonderful, beautifully preserved frog that is really one of a kind, regardless of what some Neanderthals will tell you. Lysorophia. So this entry refers to an order of small, extremely elongated amphibians that are usually considered part of the Microsauria, though some studies have said that they are instead basal reptilomorphs. Regardless, they are another group that convergently evolved an elongated snake-like body with short, tiny legs akin to those of modern-day amphibians. Interestingly, they had extensive sculpting on the roof of their head, indicating they had a sort of head shield to aid in burrowing. They lived from the Pennsylvanian to early Permian in what is now Utah, Illinois, Britain, and Ireland. Their most well-known member being brachydelans that ranged from 2 to 2.4 feet in overall length. Brachiopods. So this entry refers to the Brachiopidae of temnospondyls that emerged in the early Triassic and are best represented by the small genus Batrachians. They are notable for being one of only two families of temnospondyls to make it past the Permian, with the genera Gobianops and Cenobrachiops known from the Middle to Late Jurassic, 145 million years ago, in what is now Asia. They were the sister group to the more famous family, the Chigitosauridae, which I discussed earlier and included Kulasuchus, the last temnospondyls. Sadly, these guys died out a little before that for unknown reasons. Yunnan Lake Newt. So, this entry at the literal bottom of the iceberg refers to one of the few salamanders driven to extinction by man. They seem quite resistant compared to frogs for some reason. Cyraps watzerstocki, better known as the Yunnan Lake Snake or Wolterstorff's newt, in honor of a noted German paleontologist and herpetologist who did nearly 300 papers. Discovered in 1905, it lived true to its name in the Coming Lake in Yuba, China. Sadly, it has not been captured since 1979 and is now thought to be extinct, with its extinction being due to a combination of habitat loss, pollution, and the introduction of species like goldfish that would have preyed on their eggs. Truly a tragedy. Plagiosaurids. So this entry refers to the family Plagiosauridae, which we've mentioned before. They were a group of bottom-dwelling temnospondyl. Famous members include Plagiosaurus and Gyrothorax. But there are other genera like Megaloptophthalma and Plagiosterna. They emerged in the early Triassic and lasted until its end. Nigerpiton. So this entry refers to a genus of temnospondyls, Nigerpiton, of the family Cotylosauridae, which I mentioned earlier. They are notable for a few reasons. Firstly, it was semi-aquatic, in contrast to most of its group that were more terrestrial, and had nasty teeth which were so large that they may have peeked through the skull. It also lived in the African continent, specifically Nigeria, in the Changenian stage of the late Permian, around 259 to 252 million years ago, which greatly extended the existence of the clade, formerly thought to have only lived in Europe/America and dying out in the early Permian. Geoffreostegids. So this entry here refers to the order Geoffreostegida, which consists of only the family Geoffreostegidae, which itself contains three genera, Bruchnerpiton, Eusarptella, and the most well-known, Geoffrostegus. These early reptilomorphs are known only from the Pennsylvanian and what is now Germany, the Czech Republic, and the eastern United States. In life, they were small lizard-like things that had aquatic larvae but were otherwise fully terrestrial as adults. Lydecarinids. So this entry refers to another family of temnospondyls. Generally, they were somewhat small in size, usually reaching about maybe 3 feet in length. They were fairly widespread, being known from Russia, Antarctica, Australia, India, Greenland, South Africa, and Madagascar. It was short-lived, only found in the early Triassic around 252.3 to 247.2 million years ago. They are generally considered to be stem stereospondyls, though their classification is ambiguous, with what exactly is part of the family being highly debated, with some saying the family Lapilosidae possibly falling in it, though we'll talk about that family later. The most famous member of the family is Lydescaria itself. Brumistega. So this entry sees our final return to the family Rhinosuchidae, with the genus Brumastega. In life, it was fairly unimpressive compared to its relatives, as it only reached 11.8 inches long, being paedomorphic taxa, i.e., it retained traits of younger individuals of the group into adulthood. However, it makes up for its size in a few ways. First, it is the only member of its family to be found in the Triassic, dating 251 to 249 million years ago, making it a relic that was rare in what is now South Africa. And second, in 2013, a member of the genus was found cuddling next to a Thraxodon, an early relative of mammals. It seems that much like modern amphibians, it would enter into the burrows of other animals to escape dry conditions and heal some broken ribs in the process, but ended up getting buried in a mudslide that drowned it and the mammal. With that, we come to the end of another layer. As we descend beneath the iceberg, we shall meet creatures only the most die-hard of amphibian and paleontologists know about. Lapilopsids. So this entry refers to the family Lapilosidae, which I mentioned earlier. These were small stereospondylus that filled the niches of lizards and salamanders during the early Permian around 251 to 247 million years ago in what is now Australia, India, and Antarctica. They are most well known for the genera Manubantilia and Lapilopsis. Ventastega. So, this entry refers to yet another basal amphibian that dates to the Phanomanian stage of the late Devonian, 376.1 to 360 million years ago, in the Katyeri Formation of Latvia. The name comes from the Venta River that it was near its discovery site. It would have been living in a tidal environment where it could breathe air, which helped it to deal with anoxic conditions. And in terms of anatomy, it's thought to be more related to tetrapods than Acanthostega, but less related than Ichthyostega. But this is heavily disputed. Colosteids. The Colostidae that this entry represents are a family of stem tetrapods that are a very contentious placement, are generally thought to be predating the split between modern amphibians and amniotes. They would have, you guessed it, been semi-aquatic predators, with the largest Greeropterodon reaching up to 4.9 feet in length. Unlike later temnospondyls, their large flat skulls consisted of multiple bones, and their lateral lines were structured in a novel manner. They lived from the Visean stage of the Mississippi 346 million years ago until the Moscovian stage of the Pennsylvanian around 330 or so million years ago in North America and Scotland. Mount Glorious Day Frog. So this entry refers to the recently extinct species Tautodactylus diurnus, better known as the southern day frog, Mount Glorious torrent frog, and of course the Mount Glorious day frog. It was a member of the Batrachidae family, better known as the Australian ground frogs. Same family as the gastric brooding frogs, by the way. In life, this species was small, reaching only 1.2 inches long, and having a creamy white to bluish-gray skin tone, occasionally mottled with gray spots. It was found in the Blackall, Poangular, and Conodale mountain ranges among the banks of temporary and permanent streams. First discovered in 1966, in the 1970s it rapidly declined. It was last seen sometime in 1979. Reasons for this sudden extinction include the spread of feral hogs, which muddied waters with mud and their poop, as well as directly eating frogs, the spread of citrid fungus, habitat loss, and the invasive plants Latana camari and mistflower. This was not the only member of its genus to go extinct. Sadly, as Tandactylus acuntirostris, better known as the sharp-snouted day frog or sharp-nosed torrent frog, died out due to the same fungus. Luckily, there are still 4 species of this genus alive, being found in northern Australia. Microbranchus. So this entry refers to the species Microbranchus Spelicani, which is the only member of the family Microbranchidae, which itself is generally thought to be out of the contentious order Microsauria. It was small at 6 inches long, with over 40 vertebrae. It would have swum much like a fish, and is thought to have been paedomorphic, filling a niche akin to the modern axolotl/mud puppies. Micropholids. So this entry refers to a family of small, mostly terrestrial temnospondyls, formerly included within the family Amphibianidae, but is now found that the grouping was paraphyletic, so was split off. Regardless, they were fairly diverse and successful, with 6 genera ranging from the Pennsylvanian 307.1 million years ago until the early Triassic. They were very close to the origins of modern amphibians, but are generally thought not to be their direct ancestor. Well-known members include Micropholus, Eoscorpus, and Rubertostralia. Plagiosuchus. So this entry refers to the genus Plagiosuchus, which, as only one species, Plagiosuchus depressus, first described in 1914 by the depressed German scientist Otto Max Johannes Jekyll. It gave the family and superfamily its name, and while not the most famous of the group, it is the most representative of the group. Sclerothorax. With this entry, we see another aberrant temnospondyle, that being Sclerothorax hypiscelontus. It is the only member of the family Sclerothoracidae and is considered part of the Capitosauria group I mentioned earlier. It was 3 feet 11 inches long and most famous for its long neural spines that may have formed a sail on its back, but that's kind of contentious. It was also much more terrestrial than most capitosaurs, with robust legs. It also had the largest clavicle bone proportional to its size of any temnospondyle, and lived in the Oleckian stage of the early Triassic 251 or so million years ago in what is now Germany. Amphibimus. So with this entry, we refer to the species of temnospondyle amphibians that dates to the middle Pennsylvania to North America. It was a small animal reaching about 7.9 inches in length. As you might have guessed by its name, it was amphibious in nature, with robust legs capable of movement over land and an oar-shaped tail capable of swimming. You can probably tell that it's generally thought to be related to the common ancestor of all modern amphibians, though it's generally no longer thought to be the ancestor or even their closest kin. Legreneur. And with this one entry, we finally come to the last one related to the plagiosauroids. But this family, Legreneur gracilis, is notable for a few reasons. First, it is the only member of the monotypic Legreneur family, and is a sister group to all other plagiosaurs that are otherwise very morphologically conservative. And unlike them and most other temnospondyls, it was fairly terrestrial and covered in scales. It likely lived as an ambush predator, but wasn't very long-lasting, as it's only known from the Anzian stage, around 251.9 million to 241 million years ago. Limnoscelids. So this entry sees us return to the Didecamorpha with the second family, the Limnoscelidae. Unlike their more terrestrial herbivorous diadectid relatives, these guys were semi-aquatic carnivores/piscivores, filling a role akin to an alligator. They're also much less diverse, consisting of only one genus, Limnoscelis, which had 2 species, the largest of which reaching 7 feet long, from the Pennsylvanian around 306.5 million years ago until the early Permian, 295 million years ago, in what is now New Mexico and Colorado. Overall, a neat, if a bit short-lived, group of animals. Eocaecilia micropodia. Alright, so this entry refers to the oldest non-controversial fossil caecilian we know of, dating to the early Jurassic around 198 to 178 million years ago in what is now Arizona. This small 5.9-inch long creature is widely considered to be the oldest true Sicilian. Unlike modern Sicilians, though, it still had fairly well-developed eyes and short but functional legs. It does resemble salamanders and many microsaurs, which didn't really end up helping us understand the origins of the group, but, still kind of neat. Sclerocephalus. So, with this entry, we refer to the temnospondyls with the genus Sclerocephalus, which is the only member of the family, the Sclerocephalidae. It contained 45 species and lived during the end of Pennsylvania around 201 million years ago until the beginning of the early Permian, 297 million years ago in what is now Germany. It would have been a 4.9-foot semi-aquatic predator that fed on fish like Parambipterus. Its taxonomic placement in temnospondyls is disputed, initially thought to be related to the Eurypoids, like the famous Euryops, but more recent research indicates that it's more related to the Archaeosauroidea superfamily, who includes the gigantic Prionosuchus. Recumbrostra. With this entry, we return to the highly controversial Macrosauria lepospondylus with the clade Recumbrostra, which lived from the late Pennsylvania 323.2 million years ago until the very early Permian. They were a highly diverse group with numerous families. We already met one, the Pantelidae, but there were many others we shall meet later on that range from lizard-like forms to more lengthy snake-like ones. As you might expect, however, there's been a great deal of controversy regarding their placement and contents. While currently thought to be part of the Macrosauria, which itself is contentious, as I mentioned before, it has also been said that they may be reptiles or stem amniotes. All of this is very contentious and likely to change in the future. Batrachians. So this entry refers to another family of Eurypoid temnospondyls that lived during the Pennsylvanian and early Permian. They were fairly diverse, with 4 genera, and are notable for being large-headed, with spiky horns on their skull, and a unique hole in their head indicates that they may have had a gland for producing sticky tongue liquids. Adelogryinids. And so this entry, it refers to the larger of the two families of the lepospondyl order Adelospondyls that we mentioned earlier, containing 4 genera, including the poorly known Dolichoparsius, Adelogryinus, and Paleomologophus, as well as the most famous member of the order, the Adelospondylus of Scotland. And with that, we conclude yet another layer of the iceberg. Now we descend into the open ocean, where things become even more obscure and niche. Jalpa false brook salamander. So here we see, sadly, the second of 3 species of modern salamanders driven to recent extinction. Pseudoerysia speculata, better known as the Jalpa false brook salamander, a small animal. Physically, the animal was a dark brownish color with a bluish-gray belly. It was endemic to the area west of the Cerro Mirandamunda in Guatemala. It lived in broadleaf forests, staying damp in bromeliads and burrows of wood-boring beetles. First discovered by the herpetologist Lawrence Cooper Stewart in 1952, it was once common in the region, but rapidly declined in the 1970s, with the last individual seen in 1976. Their reasons for this extinction are due to excessive logging and livestock farming that destroyed the habitat. Luckily, the genus it belongs to, the false brook salamanders, Pseudoerysia, still have over 30 species found in Central America. Cynostega. Here we see another one of those basal stem amphibians, known from the late Devonian. As you can tell by its name, which means Chinese roof, it comes from China, specifically the Ningxiang Autonomous Region in northwestern China. It is notable for being the first Devonian tetrapod from Asia, but little of it is known due to being just a little scrap of a lower jawbone. Halurosaurids. With this entry, we return to the temnospondyls with the family Haliosauridae, generally considered to be relatives to Mastodontosaurus, I discussed earlier. They were fairly long-lasting, emerging in the Middle Triassic and lasting until the end Triassic. They were not that diverse, only having 3 genera, the most notable of which is Eocyclotosaurus, which measured around 3 feet long. Osteocephalids. So this entry refers to the family Osteocephalidae of the aestropods that I discussed much earlier on this iceberg. Like other aestropods, they had a greatly elongated body. They are distinct from the other major group, the Phalangelithalidoidea, by having robust skulls with narrow snouts. It consists of 2 genera, Coloradorpedon and Osteocephalus from the Pennsylvanian period, 310 to 302 million years ago, in Ohio, Colorado, Illinois, England, and the Czech Republic. Tessia Jaya. With this entry, we come to the last one related to the Didecamorpha, with the family Sagaridae, represented by a single, nearly complete specimen of the animal Chisazaria campi. The weird name comes from a name of a nearby landmark by the Navajo people. In life, it was a small animal, only 3 feet long, and generalistic. That sort of shows what the ancestral state of Didecamorphs was like and where they come from, i.e., North America. Kermitops. So this entry refers to a small genus of amphibiformes temnospondyls that got fame and a name based on how its face kinda sorta looks like Kermit the famous frog muppet. I don't really see it looking any more like that than some other members of this clade, but it's still a cute little critter that is likely close to the modern amphibians and got a lot of media attention. Chronosuchia. So this entry refers to the reptilomorph Chronosuchia order, which are interesting for they are the only reptilomorphs outside of amniotes to make it past the end Permian mass extinction event, better known as the Great Dying, and lasted until the late Triassic, where it seems that they were outcompeted by more derived true reptiles like phytosaurs. Notable traits of theirs include a heavy set of scales on the back, which interlocked and served as armor against larger synapsid predators as well as pseudosuchians, and helped to strengthen their axial skeleton. Zatraches. So this entry refers to the most well-known genus of the family Zatrachidae that I discussed earlier in the iceberg. It was a pretty decently sized animal, reaching 29.5 inches long. It had a huge flat head with a lot of spines on its back. Plus, there's a hole which may have housed a gland that allowed it to shoot out a sticky tongue to eat prey, and would have been primarily terrestrial. It lived from the Pennsylvanian 303 million years ago until the early Permian 272 million years ago, in what is now North America. It was first discovered in 1878 by Edward Drinker Cope. Myoprotus. With this entry, we spring forwards into the Middle Miocene with the genus Myoprotus. They were relatives to the olm, possibly ancestral to it, though it wasn't a cave dweller, and lived more like a mud puppy of the genus Necturus. Yeah, did you know that the olms and mud puppies were part of a larger group called the Protidae and are actually particularly close relatives? This particular genus, Myoprotus, had 2 species and lasted until the Middle Pleistocene, where cooling conditions drove them to extinction due to causing their habitat to dry out. Tetrapoda. So this entry refers to one of the most ancient fossil frogs known, though this is a bit contentious, as while the previously named Triadobatrachus dates solidly to 250 million years ago in the early Triassic, Tetrapoda ranges potentially either 251.3 to 247.2 million years ago. So either it's slightly older or younger, depending on what the actual date is. Found in Poland, it would have looked much like a frog, but with a short, cute little tail and probably couldn't hop all that well. Inatosuchus. With this entry, we once again cover a temnospondyl, with the focus being the species Intasuchus sylvicola, the only member of the family Intasucidae, widely recognized, though a handful of others have also been potentially added and removed again in the past. The family is only known from the Guadalupian stage of the Permian 272.5 million years ago in what is now Russia, and is thought to be part of the Archaeosauroidea superfamily, and it would have been a fish eater. Paleobatrachids. For this entry, we return yet again to the frogs with the extinct family Paleobatrachidae. Unlike the others, its classification is very well known, for it rests within the frog-clade Pipoidea, that it includes the Rhinophrynidae, which includes such living fossils as the Mexican burrowing toad and the Pipidae, which includes the Suriname toad and the clawed frogs. Back on topic, the Paleobatrachidae are the sister group to the Pipidae, emerging in the Campanian stage of the Cretaceous 83.6 million years ago. There were two genera, Albanibatrachus and Paleobatrachus, that were primarily aquatic, and they survived quite recently in southern Russia until the mid-Pleistocene cool and drying trend finished them off. Yaksha Pereti. With this entry, we shall be saying goodbye to the Albanerpetontids with the species Yaksha Pereti, named after Yashakaba, a guardian spirit in India mythology, as well as Dr. Adolf Pereti, who is a Swiss geologist and the only living person with an animal and a mineral named after him. Initially thought of as a stem chameleon, further research showed it to be an Albanternopetid and the best preserved one, due to being 3D instead of crushed flat like others, showing that at least some members of this clade had chameleon-like tongues. It is also the only member of the group known from amber, specifically Burmese amber, which is a highly controversial topic that I mentioned earlier, that a lot of people have strong, uninformed opinions on, and is actually, honestly, really interesting of a topic that I made a video about. Regardless, it's a beautiful and important find, and it's a good thing studying this animal wasn't banned based on flimsy reasoning of paleo Twitter / paleo blue sky. Thaumastosaurus. So, this entry refers to Thaumastosaurus, which, despite the name, which means marvelous lizard in Latin, is an extinct genus of frogs. In terms of their taxonomy, they are considered part of the Pixie-Cephalidae, which includes the famous African bullfrog. However, back in the past, it seems they had a much wider distribution into Western Europe, including France, England, and Switzerland. This indicates that they sort of filled a niche held by true frogs today in the region, but it seems that the cooling and drying trends of the Eocene-Oligocene extinction event impacted them severely. What is most famous about them, however, is that there have been several quote-unquote mummified specimens, which allowed scientists to really make an accurate reconstruction of them, which are very interesting. Crawlies. So with this entry, we return to the salamanders, or more broadly the Caudata, which is the clade that includes crowned salamanders and their kin that are close to them but not quite there. Like the subject of this entry, Crawlidae, which dates from the Bathonian stage of the Jurassic around 168.2 million years ago until the Aptian stage of the early Cretaceous 121 million years ago or so. In life, they would have looked like modern, robust mole salamanders, with some burrowing and neotenic members. The most famous form was Charosaurus, what is now Kazakhstan, and reached 7.9 inches in total length. Sahara Stega. So in this entry, we come to the last of the stegas, with the species Sahara Stega moradiensis. True to its name, it's found in the Sahara, specifically the Moradi Formation of Niger. Known from a skull lacking a lower jaw found by Christian Alfred Sidor, an American paleontologist, it dated to the late Permian around 251 to 226 million years ago. Its position in temnospondylus is heavily disputed, but is generally thought to be a basal form, either stem concylosaurid or Edopoidea. Acherodon Amphibian. So with this entry, we say goodbye to the order Adelospondyle with Arthropods Caledonae, which is the only member of the second family of the order, the Ascarrunz, known only from a single specimen that dates to the Visian stage of the Middle Mississippian around 346.7 to 330.9 million years ago in what is now Scotland. It is generally thought to be basal to the others in this order of already contentious basal tetrapods. And with that, we come to the end of yet another layer. As we dive deeper into deeper waters, we start to lose the light as things become ever more obscured and less well known, darkened by the darkness of obscurity. Phalangothontids. So with this entry, we again say goodbye to a major group, the Aestopod. The Phalangothontoidea consist of one stem genera, Pseudopelagontia, and the family Pelagothontidae, consisting of two genera, Pelagontia and Pseucoptia. Unlike the earlier ones, they converged even more so on snakes, with a light skull that opened wider than earlier forms, allowing them to tackle prey more effectively. They lived from the Pennsylvanian until the early Permian, and the largest species could reach 3.3 feet in length. Hapsidopalaids. So here, with this entry, we return to that highly contentious order of little amphibians that are the microsaurs as lepospondylus, with the Hapsidopalaidae. They are only known from the early Permian around 289 million years ago or so until 286 million years ago from the U.S. state of Oklahoma and Europe. The family is distinguished by a large temporal embayment near the cheek region and a greatly reduced or absent quadralojugus bone. The position of the group is disputed, but are generally thought to be part of the suborder Tudinomorpha, which itself is sister to the Osteodolepidae, which we'll meet later. The exact makeup of the family is also contentious, such that only Hopsidoporamion and Listroius are included, but they may represent growth stages of the same animal. The third genus, Saxonurpedon, may not fall in this group either. White nose bubble nest frog. With this entry, we go to a far more recent loss, with Pseudopilatus lurcorinus, better known as the white-nosed bubble nest frog, the white-nosed scrub frog, the pointed-nosed scrub frog, or Martin scrub frog. It lived in what is now Sri Lanka and reached only 0.8 inches in length, with a flattened head and a pale brownish-yellow coloration outside of the nose. It is only known from the holotype specimen collected back in 1856, and the extinction of it has an unknown cause, but likely related to habitat loss caused by the urbanization of the region. It was part of the genus Pseudopilatus, better known as shrub frogs, and they fill a niche held by tree frogs elsewhere in the world, being found in the western Ghats of India and Sri Lanka. Unfortunately, of the 78 species, in addition to the one we already talked about, 11 or so have been driven to extinction thanks to habitat loss. These include Pseudophylatus nanus, better known as the southern shrub frog, Pseudophylatus nashutus, aka the sharp-nosed pygmy tree frog, Pseudophylatus rugatus, also known as the farmland shrub frog, Pseudophylatus zal, also called the white-blotched shrub frog, Pseudophylatus extirpo, also referred to as the blunt-snouted shrub frog, Pseudophylatus hali, also referred to as the Platypola shrub frog, Pseudophylatus zimmeri, also known as the Rhombosala shrub frog, Pseudophylatus temporalis, Pseudophylatus aspergicus, Pseudophylatus dimbulae, and Pseudophylatus eximimus. And those are so obscure they don't even have common names. As you can tell, there was a lot lost, and a lot of them don't really have much information on them. Heck, they don't even have common names in some cases, but I thought combining them into one entry would be the best, if only to avoid a repetition. So, yeah, shrub frogs have had it really bad in Sri Lanka. Dasyceps. So, for our final entry based on the Zatrachidae, we have Dasyceps, which contained two species that lived during the early Permian of what is now the UK. It was the longest of the group, with a skull that reached 11 inches in length, which is just massive. Jormungander halti. So this entry, as you might know if you played the new slightly overrated God of War games, this small genus of uncertain placement microsaur is named after the famous world serpent. It was extremely tiny though, so I don't really see where the name comes from outside of the snake-like body that he used to slither through soil/mud, but I don't know, Norse mythology is cool, I guess. Mastodonsaurids. So, this entry refers to a family of temnospondyls we have actually referred to before, albeit briefly, and only their most famous member, Mastodonsaurus, is well known. But the family as a whole is far more diverse, with around 20 or so genera that spanned nearly the entire Triassic, filling niches akin to modern crocodiles. With large heads, they likely would have fed on fish and smaller tetrapods. Generally large, the smallest Waltungosaurus only reached 3 feet, and some notable examples include Paracyclosaurus, Eriosuchus, Xenotolsuchus, and Stonocephalus. Theotonius. So the end Cretaceous mass extinction is famous for the fauna it wiped out. Dinosaurs, pterosaurs, most marine reptiles, ammonites, belemnites, and rudists, all gone. Amphibians, however, generally were not as impacted due to a combination of being small and living in freshwater habitats that are generally less impacted by mass extinctions. However, there was one species of frog, Theotonius lanciensis, that lived in what is now Utah/Montana and New Jersey, that was unlucky and was established to have gone extinct to this mass extinction. And funny enough, that's the only thing it's known for, which is just kind of sad, really. Paleoplethodon hispaniola. So this entry refers to the only fossil representative of the salamander family Plethodontidae, better known as the lungless salamanders due to lacking lungs and breathing through their skin. They split off from their sister family, the Amphiumidae, quite a while back. Those guys are better known as the Amphiumas. Back on topic, the Paleoplethodontidae is thought to be a stem member of the Bolitogloss subtribe, which today includes 140 or so salamander species and is one of the largest groups of the salamanders in the world, and represent a recent colonization of South America via central Mexico. It is exquisitely preserved in the amber of the Dominican Republic and is the only salamander known to have existed in the Caribbean, living 20 to 15 years ago and apparently arrived likely through rafting over and died out likely due to climate change drying out the region. Calobatrachus. So here we see another extinct genus of frogs, Calobatrachus sainensis, discovered in what is now Liaoning, China. Dating to the early Cretaceous 125 million years ago, it is generally thought to be the oldest frog of non-contentious placement, as unlike bees, bufo, or Checobatrachus, it is part of the crown group of frogs, closer to the Aelitidae than, say, the tailed frogs of the family Ascarrunz, or the New Zealand primitive frogs Leopelmatidae. Divinosauria. So this entry refers to a group of temnospondyls within the suborder Divinosauria. They are distinguished from other temnospondyls by the reduction of the otic notch in the posterior margin of most temnospondyle skulls, the loss of a phalange on the pterygoid, which are paired bones that are part of the palate, emerging in the Pennsylvania 279.5 million years ago, in the form of such things as Trimerocarynchus. They exploded in diversity during the Permian with such genera as the fully aquatic gill-bearing 40-inch long Divinosaurus. The Great Dying hit them hard, but managed to persist into the early Triassic 251.3 million years ago. Latonia gigantea. Alright, so for this entry, we're once again going to the frogs, with the genus Latoni actually still existing in the form of the relic Latonia nigriventer in Lake Hula, also known as the Lake Hula frog in northern Israel. It is highly endangered and would likely be destroyed if, say, another Palestinian-esque government took over, as the reason that they're so rare is due to Arab mismanagement of land, but I'm sure Israel is really at fault here, clearly. Regardless, the genus once had many species ranging across Europe, from the Oligocene to the Pleistocene. The most notable is the topic of this entry, Latonia gigantea from the Miocene, which could reach 11 inches long, only 1 inch shorter than the largest frog alive today. Trematosaurids. So this entry has a swirl back to the temnospondylus with the family Trematosauridae, which itself is divided into two subfamilies. The more land crocodile-like Trematosaurines that had 6 genera, such as the namesake Trematosaurus, Trematosuchus, and the unusually broad-snouted Tortrema, and the more gharial-like subfamily Loncorhynchidae, which had 5 genera. Notable ones included Aphenorama and Wantosaurus. These guys are distinct from all other temnospondyls thanks to their ability to tolerate salt water and marine habitats, something no other amphibian group has ever done, filling niches that were empty due to the Great Dying. Emerging in the Triassic 251.9 million years ago, they seem to be gone by the period's end, but a possible fragment found in China may mean that they persisted as a relic into late Jurassic, area of China. Orochordylids. So this entry refers to the Nectridian lipospondyle family, Orochordylidae. They are close relatives of the more famous Diplocolidae I mentioned earlier, but unlike them, they lack the large heads, and instead being mostly normal aquatic-like animals that had paddle-like tails and a loose connection between bones that make up the jaw. They consist of two subfamilies, the more pointed skull Sauroplurinae, best represented by Sauroplura, and the short-skulled Orocondylidae, best represented by the genus Orochordylus, the best known of the entire family. They are only known from the Pennsylvania around 323.2 to 298.9 million years ago. Idiobrachiops. So this entry is the best representative of the family Phytidiosteidae, which are a nice group of small temnospondyls that were the sister group to the more famous Brachiopoideae, living from the late Permian and surviving until the late Triassic. Idiobrachiops, alongside others like Truchiosaurus and Nanolania, were semi-aquatic animals akin to modern salamanders. Rubricocelia monbaroni. So, for our last entry in this layer, we shall be returning to the bag of mysteries, that is, the Caecilians, with the species Rubricocelia monbaroni, dating to the Berrixian stage, aka the earliest part of the Cretaceous, around 145 to 139.8 million years ago, in what is now Morocco. Due to its fragmentary nature of being only known from a jaw, it's hard to know if it still had legs, but given that while more derived than Eocecilian, it was still more basal than modern ones, it's reasonable speculation that it may have had some really small ones if you really want to depict them with it. And with that, we come to the end of yet another layer. As we descend deeper, the light is nearly gone. We meet creatures even more obscure and niche. Welcome to the Twilight Zone. Do 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 do. Gazia. So this entry refers to the species Gazia genei, which was a stemmed tetrapod of uncertain placement, though generally is thought to be close to colostiids, which I discussed back on Layer 5. While only known from a flattened skull and thus can't be 100% certain, it is thought to have been around 8.2 to 13 feet in length. But what makes it most notable is that it dates to the early Permian, 280 million years ago, long after other stemmed tetrapods went extinct due to the Carboniferous rainforest collapse, as well as the arrival of more derived tetrapods. It is known from the Nani Bua, but after some further research, it was shown that at the time it would have been in the South Pole, making this the Paleozoic equivalent of Koolasuchus, a relic from a long-lost time. µCT. So this entry refers to the species µCT melanolimnectis, whose name means the true creature from the Black Lagoon, a reference to the 1954 horror film, dating to the Visean stage of the Mississippi in around 345.3 to 330.9 million years ago in what is now Scotland. It was notable for being one of the first to have buccal pumping, the type of breathing used in modern amphibians. And its taxonomic placement is generally thought to be the most basal batrachomorph, which, is the clade that includes all modern amphibians and temnospondyls. So it's very important in that regard. Rhynchocos. So this entry refers to another genus of microsaurs that is known from the early Permian of Oklahoma. It had a very long body with short legs, originally thought to be potentially the ancestor of caecilians due to the similarity between it and Eocaecilia. It's now thought that this was due to convergent evolution, and as you've been paying attention in this video, there's a lot of different times that amphibians have evolved a long, lengthy body with reduced or absent legs, much like a snake. I guess you could say it's a bit of a trope at this point. West Lothiana. Alright, so this may be my most contentious inclusion alongside Tiktaalik for certain people. West Lothiana lizzie, which is a reference to the nickname Lizzie the Lizard that the fossil discoverers gave it, is not a lizard. Nor is it even considered the first reptile, at least by some. It is now thought to be a reptilomorph, albeit the one closest to true amniotes, which is the group that includes reptiles and the like. In life it was small, only reaching 7.8 inches long, and lived in bogs in what is now Scotland during the Visean stage of the Mississippi around 338 million years ago. We have a lot of body fossils from it due to it often getting stuck in rotten logs and dying. Stenotosauриds. So with this intro, we are returning for the last time to the Mastodonasauroidea, a group of temnospondyls that we've mentioned multiple times. This is the third and least well-known and smallest of the families, the Stenosauridae. They're fairly unremarkable animals, best represented by the genus Stenotosaurus from the Middle Triassic of what is now Germany. Zakelmi-Tranquays. So this entry refers to a set of footprints found in the Zakelmi quarry in what is now Poland, dating to the Middle Devonian, predating that of Tiktaalik, the oldest quote-unquote amphibian by 10 million years, found in 2010. Many, such as creationists, took this as proof science was wrong, but further research has cast doubt on these, and several hypotheses have been proposed, such as these being trace fossils of unrelated fish feeding on benthic animals, some now extinct lobefin that converged on tetrapods but ended up not doing anything and dying out, or perhaps that animals like Tiktaalik were not our direct ancestors at all, but rather late surviving relics from an earlier Middle Devonian radiation of lobefins, and that these trackways are our true ancestors. Chunurpeton. So this entry refers to an extinct genus of salamanders, Chunurpeton trianiensis, that lived at the border near between the Middle to Late Jurassic, 164 million years ago, and what is now Inner Mongolia. It was a small animal, only reaching 7.08 inches long. In life, it was neotenic, i.e., it stayed in its larval form into adulthood. It was formerly thought to be the earliest representative of the Cryptobranchoideae, which today consists of two families, the Cryptobranchidae Branchidae, better known as the giant salamanders, and the Hyenobidae, better known as the Asian salamanders. However, more recent studies in 2022 found that in actuality it was a stem caudalatin, aka lying outside of the true salamanders, and a bit closer to them than some of the other ones we've discussed up to this point, like the Caruidae are, but still not quite true salamanders. Notobatrachus. So this intro refers to the genus of frogs, Notobatrachus, which held two species. It is perhaps the most complete Jurassic-aged frog we know about, as we even got tadpole fossils of this genus, which are also the oldest Anuran tadpoles known from the fossil record. It would have lived in floodplains that were seasonally dry and grew up in temporary pools. It was also decently sized, reaching about 5.9 inches long, dating to the 179 to 168 million years ago in what is now Patagonia. It is generally thought to be the first true frog, or at least a lot closer to them than, say, Triadobatrachus or ΜCT-Scan. Yet, unlike Calobatrachides, it's not been assigned to any modern group. Gunther's streamlined frog. So here we see the species Nanophrys guntheri, more well known as Gunther's streamlined frog. It was a small animal only reaching 1.12 inches long and was endemic to Sri Lanka. This was a mistake, as it went extinct sometime in the 1890s/1920s due to habitat loss and has not been seen since the original specimen was collected in 1882 by British zoologist George Albert Boulanger. It was a member of the family Dichoroglossidae, better known as the fork-tongued frogs, and while it sadly may be gone, the other three species of the genus still exist. The vulnerable Nanophragis cilianis, better known as the Sri Lankan rock frog or the Salian's streamlined frog, the endangered Nanophragis marmorata, better known as the Curtius ingisis rock frog or the marbled streamlined frog, and the also endangered Nanophragis mayrakai, better known as the Sri Lankan tribal rock frog. So yeah, there's still some hope for this group. Jeholotriton. So this entry refers to another extinct species of salamander found in the Diaoyu beds of Inner Mongolia that date to the Jurassic 164 million years ago. It had a strange skull morphology, originally thought to be part of the suborder Cryptobranchoidea. It has been in recent years found to fall outside the group of true salamanders, being more basal. Phylospondyle. So in this entry, we refer to, much like Labyrinthiodont, a now invalid paraphyletic wastebasket taxon, phylospondylls, which are distinguished by features of the vertebrae which consist of neural arches over an otherwise non-ossified notochord. It is now thought to have been a collection of small neotenic animals like Brachiosaurus and is no longer used, but I think was worth mentioning due to showing up in old papers, yet it never achieved the success/fame of the term Labyrinthiodont in pop culture, so isn't as well known. Habrosaurus. So this entry refers to another extinct salamander, specifically of the family Sirenidae, better known as sirens. They are an ancient group that has undergone a lot of recent research/discoveries in recent years, but that's a subject for another day whenever I eventually discuss the amphibians of Mississippi. Back on topic, Habrosaurus was a genus of two species that were massive, with the largest one reaching 5 feet 3 inches in length. It is also known from the Hell Creek Formation, meaning it coexisted with T-Rex, though I doubt either of them met each other recently. And it actually outlasted them, living until the Paleocene 58.7 million years ago. Hyloplesian. So this entry refers to the genus Hyloplesian, which is the only member of the family Hyloplesiodontidae, which are part of the contentious collection of small amphibians called Microsauria. It was a small semi-aquatic animal that reached 3 inches long and had 3 fingers, a condition called tridactyly, which it got independently of other groups of tetrapods. Arizonerpiton. With this entry, we shall be returning once again to the order Nectridia with the species Arizonerpiton, Wellsi, that dates to the Middle Pennsylvania around 314 to 311 million years ago. in what you may have guessed is now Arizona. It is basal outside of the other families and is distinguished by bifurcate neural spines. Sadly, there's not a lot of good pictures of it out there, but it is a very interesting animal. Rana basaltica. So this entry refers to a far more recent animal, Rana basaltica, reaching only 1.8 inches long in length. In life, it would look like your average frog, but it is notable for it dates to the early/middle Miocene, about 15.97 to 11.6 million years ago in what is now China, and represents the oldest non-contentious member of the famous genus of frogs, Rana, which was the frog that Carl Linnaeus first scientifically described. So, kind of interesting to see how recent a lot of things we consider commonplace are. Ulsoniforms. So, for our final entry in this layer, we should be covering a clade of Discophoridea temnospondyls, generally thought of as being closely related to the amphibiformes. That's kind of close to modern amphibians, though this is, as always, heavily disputed. They are divided into two families, the Trematopidae, best represented by the genus Acalia and Conastes, Edexia and such, and the other being the Discorophidae, who are a bit more well known. With that, we come to the end of yet another layer. All light is lost as we descend further into the darkness of obscurity. Welcome to the Abyss. Spathicephalus. So this entry refers to the stem amphibian Spathicephalus, which lived during the Mississippian 326 million years ago until the Pennsylvanian around 313 million years ago. It is most notable for being in a completely different niche than most basal tetrapods, living as a suction-feeding filter feeder of invertebrates and small fish. It is known from Nova Scotia and Scotland. It is generally thought to be part of the superfamily Baphetoidea, which I mentioned earlier, and included the Baphetidae that, again, I discussed earlier. Skincosaurids. So this entry, we shall be taking our last visit to the Nectridians, which are the group that includes the famous Diplodocus, with the smallest and most obscure of the three families, Skinosauridae. These guys are distinct from the others by being more terrestrial. They lived in the Moscovian stage of the Pennsylvanian 305 million years ago until the early Permian 266 million years ago, and consisted of two genera, Skincosaurus and Saurorus, which would have looked a lot like lizards or newts. Osteodolepids. So in this entry, we shall be discussing the Osteolipidae, which are a group of Recumbrifera microsaurs. They are distinguished by a well-ossified skull, elongated bodies, short tails, and robust limbs. They are best represented by the like of Peltostotis and Nanorator, which are thought to have been fossorial. The group lived in the early Permian. Dendreptontids. So here we return to the temnospondyls with the family Dendreptontidae, which are known from the Visean stage of the Mississippian around 346.7 million years ago and lasted until the Westphalian stage of the Pennsylvanian around 309 million years ago. This was a small family both in terms of numbers, with only the genera Dendrepodon and Balaenopodon, as well as physically, with both only being a little over a foot in length. In terms of taxonomy, they are considered to be the most basal of the Temnospondyli, which are the group that includes all but the Edopoids, and are basically the more derived group of temnospondyls. These are the first of them. Paleoamphiuma. So with this entry, we go to an actual salamander, Paleoamphiuma tetradactylum, dating back to the early Eocene of what is now Wyoming, 55.5 to 50.5 million years ago. It could reach up to 15.3 inches in size, and true to its name, it had 4 fingers and was thought to be the ancestors of the modern genus Amphiuma, which today live in the American Southeast, and I personally have seen at least 2 of the species. But further research in 2003 indicates that it's actually part of the Sirenidae family, and the similarities are due to convergent evolution. Very interesting. Chinglestegogophus. Alright, so for this controversial entry, we got the late Triassic small fossorial stereospondyle that is of disputed position but may be part of the Metoposauroidea superfamily. Chinlestogophus, living in the late Triassic around 221 to 206 million years ago in what is now Colorado. It broke headlines due to being considered a possible ancestor to caecilians, which, if true, would turn modern amphibians paraphyletic, with caecilians coming from stereospondylus and frogs and salamanders coming from the discorophiids. However, more recent discoveries indicate that it may resemble caecilians due to convergence and not to being actual relatives, though I personally disagree with that for reasons we will get to later. Funcusvermes gilmore. So this entry is what I was referring to last time. Funkivermes is a stem caecilian dating to the Norian stage of the late Triassic, around 223 to 218 million years ago in what is now Arizona. Being one of the most complete caecilians known from the fossil record, it had much longer legs, though still a very long worm-like body, leading to its name, which means funky worm in Latin. It has been said to be a link between the Discophoroidea, a group of temnospondyls, and hailed as proof of the consensus of a monophyletic lissamphibia origins. And to give that idea its due, it is the oldest caecilian. However, I would caution from being too overeager for everyone. For one thing, while it does have traits that link it with caecilians, it really doesn't have much that links it with the Discophoroideas. And nothing that really rules out stereospondylus as a whole. Not saying either is true, but in reality, we just need more fossils to fully establish whether or not caecilians are in fact a monophyletic group with the other major amphibians. Procylurus. So, for this entry, we should be returning to the frogs with the species Procylurus bitis, which gets its name from a combination of the Navajo word for night, above, and the Latin word meaning to leap forwards. This is in reference to how it had mostly lost the basal traits of earlier quote-unquote frogs, like the ones I talked about earlier, but it wasn't fully part of the true Anura. It's disputed and lived in what is now Arizona, dating to the early Jurassic, 195.2 to 182 million years ago. Divinosaurs. Alright, so with this entry, we return once more to the temnospondyls. The Divinosauria, with the most famous of its members with the genus Divinosaurus, known from the Middle to late Permian, 265 to 254 million years ago, in what is now western and central Russia. Fairly diverse, it had 5 species, the newest recognized in 2024. It could have reached 7.38 feet in length, though most were 40 inches, and was fully aquatic. Peltobatrachus. So here we see another extinct, unusual species of temnospondyl, Peltobatrachus pustellatus, the sole member of the family Peltobatrachidae, which itself is usually nested within the suborder Stereospondylus, though it was radically different than most of them, being fully terrestrial outside of egg-laying, and had large armor plates akin to that of an armadillo, and would have reached 2.3 feet in length. Bayenerpeton. So here we see another extinct salamander that dates from the late Jurassic of what is now China, 157 million years ago. It is notable for being considered the oldest representative of the Salamandroidea suborder, also known as the advanced salamanders, which contain all salamanders that are not sirens or the primitive salamanders like the Asian salamanders and the giant salamanders. So it serves as an important bridge in our understanding of that group. Rachytomi. So this entry refers to yet another defunct group of amphibians, which were distinctive due to the structure of their vertebrae, which had long semicircular intercentra below the notochord and smaller pluricentra on each side of the bone and below, forming an anchoring point for ribs. It has since been abandoned due to being paraphyletic and was never really able to even enter into the wider public like Labyrinthodont has. Sierra de Omoa streamside frog. So this entry, we go forwards to the present with the species Krogenstar omarensis, better known as the Sierra de Omoa streamside frog. In life, it was a fairly unremarkable frog, being endemic to 38.6 square miles in the Sierra de Omoa of Honduras. It liked montane forests and was discovered in 1997. It declined rapidly in the early 2000s due to habitat loss and chytrid fungus disease. It was part of the genus Krongester, which contains another 125 species, of which 2 others have gone extinct as well: Kragnorstar mylon and Kragenstar anciennis. Micromelarpetontids. So this entry refers to another small group of tiny temnospondyls of the family Micrometerpodontids, which were these neotenic animals and are believed to be closely related taxonomically to the Brachiosauridae, which we will meet later on. Known from the Pennsylvanian to early Permian, they strongly converge in body form to the Microsauria, with their most famous member being the genus Micrometepretor. Latyscopids. So this entry refers to yet another small extinct family of small Triassic temnospondyls. It was a relatively minor group with only about 4 or 5 genera. The most notable of these include Chinlestegophus, though that inclusion is very contentious and it might be somewhere else, and not as contentious is the small guy known as the Ninumbihan. Yeah, I know it's a weird name. It comes from a Native American language. These would have been generally small guys that were primarily terrestrial, but also likely tunneled regularly. Yeah, they're just kind of there, but, that's why we talk about them in this iceberg. They're too obscure to get any level of attention. Phosphotriton. This entry refers to the genus of salamanders, Phosphotriton, which dates to the Eocene around 40 to 35 million years ago in the Corsi Phosphoritic Formation of what is now southern France. It is a relatively average salamander, but it is most notable for being exceptionally preserved as a mummy, with tons of soft tissue being present there. And we even get some gut contents that show that it ate frogs, which is very interesting. Rhytiosteids. So this entry refers to a family I sort of alluded back to previously, but the Rhytiosteidae were a family of small temnospondyls that lived from the late Permian until the early Triassic and are best represented by the genus Nanolambia and Arcadia. Brachiosauridae. So for our final entry of this layer, we shall be covering the family Brachiosauridae, not to be confused with the similarly named dinosaur family Brachiosauridae. These were a family of small amphibians divided into 2 subfamilies, the monotypic Tungusograinae and the more successful Brachiosaurinae, which held 6 genera such as Apenticonia and Brachiosaurus itself. As a group, they were aquatic and semi-terrestrial animals known from several growth stages, some even being neotenic. They were found throughout Middle Europe from the Pennsylvanian until the Wardian stage of the late Permian, 266 million years ago or so. Interestingly, they are considered the sister group to the living amphibians of Lissamphibia, assuming that they are a monophyletic group. And with that, we come to the end of another layer. Yet we are not done, for at the bottom of the abyss we find a deep-sea trench. Let us go deeper into the darkness of obscurity. Caryocarius. So here we come to the mysterious amphibian Caryocarius bardate, so named for its suitable spine dating to the Mississippian 340 million years ago. This terrestrial animal is of uncertain placement, but is considered one of the most basal batrachomorpha and lived in what is now Scotland. Pass stubfoot toad. So this entry refers to the species Alcalops sinex, more commonly called the pass stubfoot toad. Yes, it was a toad, a member of the genus Alecotopus, which, due to their smooth skin and more aquatic nature, are often called harlequin frogs. But I prefer harlequin toads, as they are part of the Bufonidae. Back on topic, this species could reach 1.7 inches in size, and was one of the less colorful species, being black, greenish, bluish gray, or blue-green without markings, and females being in possession of patterning that could be lemon, bright green, or cream in coloration. Endemic to the Cordelia Central in the Cordelia del Talamanca mountain ranges of Costa Rica, it lived in elevations of 3,600 to 7,200 feet. After its discovery in 1952, it underwent a massive population decline in the 1980s, with the last individual seen in 1986. This decline likely was due to a combination of climate change, the pet trade, pollution from mining, and, of course, the aforementioned citrid fungus. It's not alone, with the genus as a whole suffering extremely, with Aleopterus curacensis, better known as Lewis's stubfoot toad, or Cherokee harlequin toad, being extinct, and 70% of living species being considered critically endangered. Gymnothrids. So this entry refers to the family of Ricrombristrin microsauria. Gymnothridae, known from the Pennsylvanian to early Permian of the Czech Republic, Nova Scotia, Illinois, Oklahoma, and Texas, are unique for having a single row of comical teeth on the margin of the jaw. The most famous of the group are Gymnothorus, formerly thought to have been a reptile. Triasaurus. So with this entry, we see the oldest known salamander, dating to the youngest part of the late Triassic, 235 to 222 million years ago, in what is now Kyrgyzstan. Only known from a few skeletons, which are about an inch long. Unlike the first frog and first caecilians, it has fallen into obscurity due to, honestly, not getting a lot of coverage and, frankly, not being particularly outstanding amongst a sea of small amphibians and early salamanders. I mean, I think it's cool and underappreciated, but I admit it's not as big of a transition to go from small temnospondyle to salamander as it is to, say, go from small temnospondyle to frog or caecilian. Pangurpiton. So here we got another extinct stem salamander, Pangurpiton sinaceus, dating to around 164 million years ago during the Jurassic of what is now Liaoning, China. Unlike other stem salamanders, it would have had a stout, fat body and is found right outside the crown group of true salamanders. Teudytonids. This entry refers to the Microsauria family Teudytonidae, which were small lizard-like terrestrial amphibians. Indeed, it's thought that the similarity to reptiles may have explained their rarity in fossil deposits due to living in areas away from water. And indeed, competition with reptiles is likely what led to them having an early extinction in the Pennsylvanian. They consisted of three genera, Teudytaurus, Crinodon, and my boy, that's literally how his name is spelled, from Ohio, Nova Scotia, and the Czech Republic. Eldecion. So this entry refers to an early reptilomorph of uncertain placement that dates to the Visean stage of the Middle Mississippi in what is now West Lothian, Scotland. It is unique for having ribs that were restricted to the first half of the spine, which is not seen anywhere else except mammals, which they got independently. It reached 1.1 1.15 feet long and was mostly terrestrial. Bystowers paradox. So this entry refers to an issue that for a long time plagued reconstruction/inferences on the nature of gills and temnospondyls and other prehistoric amphibians, with the bones of many having similarities to those of fish, which had internal gills, but larval salamanders that had external ones. Eventually, in 2010, this paradox was solved thanks to the hard work of Ravier R. Schalland and Florian Witzerman, who determined that adults of aquatic temnospondyls likely had internal gills like fish, but the larvae had external ones similar to larval salamanders, though there were exceptions and some adult temnospondyls still had external gills. Vierella. So with this entry, we return to the frogs with the species Vierella webstri, which dates to the early Pleistocene stage of the Taurosian, 189 to 176 million years ago in what is now Argentina. It is one of the oldest true frogs. It was a small guy, only reaching 1.2 inches in length, but was found exceptionally preserved. Rhinella loba. So this entry refers to an extinct toad that dates to the late Pliocene around 3.5 million years ago and is considered closely related to the modern cane toad, Rhinella marina, infamous as being a horrible invasive in Australia. And indeed, it would have looked a lot like it, but with a notably broader skull. And it would have honestly not been that notable, and it's admittedly kind of generic, but it's important as it is the only diagnosable extinct true toad of South America's fossil record. Triadobatrachus. So with this entry, we will be saying goodbye to the Divinosauria temnospondyls with the second of the two families, the Trimerorachidae. It's a relatively small family consisting of around 4 genera, the most notable of which being Trimerorachus itself, Neldasaurus, and Procouia. Matthew's giant salamander. So with this entry, we shall meet the largest salamander, true salamander, remember temnospondyls don't count, to have ever existed, Andreas Matthewi, which reached 7 feet 7 inches long, rivaling some of the average-sized temnospondyls and taller than most people. It lived from the Archean stage of the Oligocene around 30.6 million years ago until the Barstonian stage of the Middle Miocene around 16 million years ago or so in what is now Saskatchewan, Colorado, and Nebraska. And it seems to have been more terrestrial, at least a little bit, and was negatively impacted by the drying that occurred at that time. Trematopods. Here we see another entry related to some small temnospondyls. The family Trematopsida were a family of mostly terrestrial animals that lived from the Pennsylvanian 305 million years ago or so until the early Permian 272 million years ago or so, and are distinguished from the closely related groups like the Discorophoria and the Amphibiformes by the presence of an elongated nares and are the largest of the Discophoroides. Archaeosaurids. So this specific entry refers to yet another clade of temnospondyls that converged on the body plan of those of crocodiles. We've already met the most famous member of this group, the gigantic Prionosuchus, but the rest of the family has fallen into obscurity, often wrongfully grouped together with the superficially similar but unrelated Triassic family, the Tremalosauridae. This group, however, was exclusively freshwater and limited to the Permian, from 297 to 252 million years ago. They were divided into two subfamilies, the shorter-snouted Melosauridae, which were much less diverse of the two, with only 5 genera, notable ones of which include Melosaurus and Conzucaria and Tryphosuchus. The second long-snouted subfamily of the Platyposauridae, which included 7 genera such as Platyposaurus, Colindosuchus, Bagnerpiton, Archegosaurus, and Prionosuchus itself. Cassinaria. So here we got another stem small tetrapod, Cassinaria kiddi, only reaching 5.9 inches in length at lived during the Mississippian 340 to 334 million years ago in what is now Scotland. Considered a missing link, but the lack of a skull makes this hard to confirm as to whether it is an amphibian or a reptile or something else entirely. Solenodosaurus. With this entry, we say hello to the reptilomorphs again with Solenodonsaurus, whose name means single-toothed lizard. Reaching 1.48 feet long, its placement is disputed. Either it's a reptilomorph or some kind of the lepospondylus. In life, it would have been mostly terrestrial and an active predator on smaller animals. Valdotriton. So here we got another extinct early salamander, Valdotriton gracilis, dating to the late Barrenian stage of the early Cretaceous, 125 to 130 million years ago in what is now Spain. It was small, only reaching 1.6 inches, though the total length is up for dispute as all specimens were not yet adults. It is thought to be one of the oldest non-contentious member of the Salamandroideae, better known as the advanced salamanders. Batrachosauroidids. So for the final entry of our second to last layer, we got a family of extinct true salamanders. The Batrachosauridae were a group of large paedomorphic aquatic animals whose origins and taxonomy are heavily disputed, and the oldest fossils of this group date to the Barrenian stage of the early Cretaceous around 125 million years ago or so. But these are contentious, with the oldest non-controversial members dating to the late Cretaceous of America and Europe, in the form of Opisthotriton and Prodesmodon. They have been classified as either falling outside the crown group of salamanders or being a sister group of the Protidae, which includes mud puppies and the olms. But again, this is disputed. But they survived the µCT extinction and lasted until fairly recently, only dying out in the Middle Miocene about 16 to 13 million years ago in what is now Florida. Their extinction at this date is confirmed as we see amphiumas, or Congo eels as they're often called incorrectly, and sirens growing larger to fill the niches left open for them. As to why they went extinct, it's hard to say. Climate change can be ruled out, as if that was the case, it would have wiped out those other types of salamanders which rely on the similar conditions. In truth, despite what we may believe, not all extinctions end in a bang. It's possible that they just sort of faded away over time in the bayous of Florida, lost to time, and it's kind of a shame we will never really know what happened to them. And finally, we come to the seafloor. Here in the absolute darkness, we rest upon a muddy bottom and stand to see the most obscure of all extinct amphibians and related topics of all time. Welcome to the bottom. Sylvanerpeton. So, here for this entry, we see the last of the reptilomorphs we will be discussing in this video, with the species Sylvanerpeton and Mirapedes, which is important as it dates to the Barrenian stage of the Mississippian, being one of the few terrestrial animals known from the infamous Romer's Gap. Reaching 1 foot long, you best believe that the young are believed to have been aquatic, while adults were more terrestrial, and is believed to be close to the origin of the amniotes. The Beast of Lesotho. It seems fitting that we here see the last temnospondyle entry after the reptilomorphs, but before the last of the modern amphibian group, the Beast of Lesotho references to a gigantic undescribed brachiopomorph, which I'll remind you are the group Culasuchus, the last of the temnospondyls belong to, which, based on the fragments of the jaw compared to more complete specimens like Siderops and Culasuchus, would have reached 23 feet long, meaning it was either the third or second largest temnospondyl ever, rivaling the more famous Mastodontosaurus and Prianosuchus. Man, if only someone could give this guy a scientific name, I think it would make it be a lot more famous. Amphibians don't exist. So, this Entry refers to the pedantic technicality that talked about near the beginning of the video, where amphibians as a group technically don't exist, strictly speaking. Uh, and here's the thing, that is true. We would rather use the term like batrachomorphs for like modern amphibians, or stem tetrapods, I guess, if you wanted to be more inclusive. But that's pedantic, and honestly, there's nothing wrong with you using the term amphibian to refer to most of these guys. No one's really going to side-eye you outside of the most pedantic, bad faith people on the planet, so they're just not really worth engaging with. Ainsworth salamander. Here we see our last salamander-related subject on the iceberg, Plethodon ainsworthi, also known as the Bay Spring salamander, the Catahoula salamander, and most commonly Ainsworth salamander. Originally collected in 1964 by the Jackson Harold Ainsworth, who was some field worker who otherwise hasn't seemingly done much in their life, and described it as being Plethodon glutinosus, the northern slimy salamander, as it's often better known. In 1988, the herpetologist James Lazelle, thinking that this wasn't right, coined a new name. It had been discovered in Jasper County, though its exact location was sadly lost. However, a paper in 2013 made by John G. Holmes and David C. Beckett intensively searched the area it was allegedly found and examined the specimen and found the distinguishing traits of the animal to be the result of poor preservation bias. And much like the Vegas Valley leopard frog, it is now believed to be part of an already existing species, Plethodon mississippius, the Mississippi slimy salamander. So yay! We did not lose a species of salamander in my home state. That's nice. For once, something good happened. Giant Eocene Calitocephalid. And so we come to the last frog in modern amphibian-based entry, and the second to last entry overall. So you remember Beelzebufo, right? Near the top of the iceberg? While its maximum size has been disputed, it was pretty robust. Well, what if I told you there was a frog much bigger? Meet the giant Eocene Calitocephalid, which, yes, sadly has not yet been given a proper name for unknown reasons. Calitocephalid, better known as helmeted frogs or helmeted toads, are a small family of 5 species in what is now southern South America, originating in the Campanian stage of the Cretaceous. But in the Eocene, one species, in what is now Chile, would reach 23.2 inches long. That is one big frog. I mean, goodness me. It could eat your cat, if it wanted to, probably. Every fossil is personalized. So, with our last entry, we come to what some would consider a bit of a meme. However, unlike with, say, every Bionicle set is personalized or every game copy is personalized, it's actually true because each fossil, in all likelihood, represents an individual animal preserved in time. So each of them really is unique and valuable. And with that, we come to the end of our tale. As we rise to the surface in light, let us reflect on our journey. Amphibians are an amazing group with a rich, long tapestry of history. So next time you see a frog or a newt or luckily maybe a Sicilian, do not dismiss it as some cringe meme or some relic of a long-lost age doomed to lower status by the superior amniotes, but view it as the latest in a dynasty of life that predates you, me, and will probably outlive us all. Anyway, I'm the Dark Master. If you liked the video, like it, but if you loved it, consider sharing it around. These take a lot of time to research, record, and edit, and as such, it really helps when you do that. Anyway, happy Halloween!